and then we will start. Okay, very important discussion, lot of topics we are going to discuss today, and this is really required for your career growth. Okay, so AI engineering, we know that the projects are moving towards that. Every single day in news they keep telling the movement is towards AI side. Big companies, MNCs, they are saying we need people with AI related skills. So everybody wants developers to upgrade into AI. Okay, so let's get started. This is going to be very important discussion. Let's go. Okay. Thank you for confirmation, guys. Thank you for confirmation that you can hear the voice loud and clear. Let's start with today's topic. So first of all, we will discuss what we are going to do today and then start with all the areas. Okay. So guys, the topic for today is AI engineering for Java developers. Okay, AI engineering for Java developers. And we are going to start with Spring AI. Nothing but, as we know, Spring is the framework for the Java related guys. Using Spring, we can build a lot of applications of the Java related, and Spring AI is given in order we can build AI based applications or AI applications. Okay. So guys, everyone, we can see the members have marked the poll, and like we see, majority is at the beginning area. Roughly 70% is new to all these concepts. And yes, that is where we are here in this call to be aware of that. And still 26% is in a category K. We know some basics about it, but we need to dig more. And there are 5%. So that's what is the current market situation. The aim of this is, by end of today's call, all of you who are saying okay, we don't have that much grip on these concepts, all should be comfortable with this topic. Okay, so all of these topics we are going to cover as part of today one session itself. There is no part 2, so we will connect right now for 3 hours, and roughly around 3 hours. Let's see, a bit here and there it can happen, and let's see how much we are able to finish it by the end of this time. Okay, so let's get started. So first of all, AI engineering. Okay, my quick background is something like this. As you see, my name is Tausif. I have 14 years IT experience. I started my career like Java developer. Then I became full stack. Then I became technical lead. And then further went to become manager, then senior manager, then head of technology. Okay, and then leading around 40-member teams here. Okay, and I got a chance to work in all variations of companies. I worked with startups, I worked with MNCs, I worked with product organizations, service organizations, and right now my friends are working at good big positions, senior positions in multiple IT organizations across the globe. Okay, so I'm continuously in touch with them to really understand where the market is heading, what is going on, and we keep discussing and shaping okay, what are the next actions required. So as part of this today's session, whatever this major learnings based upon current market situation, whichever is required for you guys to be aware of, we are going to do all that discussion. Okay, so every single thing will be very important. Every single topic is very important. Put your full attention here, because your next career move will need this mandatory knowledge. Okay, and it is basically for Java developers. So our focus is on Java developers, and both freshers and working professionals need this knowledge. Okay, both freshers and working professionals need it. So please put a strong attention, because the market is changing for both the guys. Okay, so wherever the market is going, so job roles of freshers are also being modified, as well as working professionals. So everybody is in the race to upgrade, become better. So both of them has the similar opportunities. Okay, now what are we going to do as part of this 3 hours together? 3 hours live, okay? So 10 a.m. onwards, we will be connecting for around maybe 1 p.m. Let's see how it goes. Our aim is Spring Framework. We know Spring Framework. In order to build any application, we need framework. And Spring is a very popular framework in the Java related world. So in the Spring Framework, they have given a module or a project called as Spring AI. Using this, we can build AI applications. What all this thing means, what is AI applications, everything we will understand today. That's what all the conceptual clarity will come, everything will happen. But Spring Framework gives capability to developers to develop any kind of a project. They have given Spring AI for building AI applications. What is AI applications, we will understand. And the current market is heading into it. And all the features of Spring AI, they have summarized it into this document. Okay, let's have a quick look. So Spring AI features, they have written this documentation about all the Spring AI related capability. You can check it out. The multiple AI concepts, how to get started, what kind of libraries, classes they offer, and all these multiple concepts. What is a chat client, advisors, prompt, structured output, multimodality, working with multiple models, chat models, embedding models, image models, chat memory concept, tool concept, MCP concept, RAG concept, model evaluation, vector databases, observability. Nothing but able to do all of these in your AI applications. That is what is the power of Spring AI. Okay. So all these terms are required when you work with AI based applications. And in order to implement all this, Spring AI is providing a strong support. So already in the market, we can see other languages like Python and other guys, they are very much leading into the AI related revolutions with algorithms and all. And they are there since long time. But now Java is also in the race. They have launched this Spring AI. And you can see the version itself, 1.0.3. So as part of that, it is providing capability to build AI application. Okay. So the aim of today's session is whatever is mentioned here in this document, we should get high level clarity about all of these things. Okay. So that you are not like blank when people talk about AI applications and what is the Java capability. So you should not be lost there. So the aim of the today's session is to understand end-to-end overview of whatever these things are. So we are not going to get into one topic and go very deep in that. We will be covering it at high level overview. So you get the big picture context of what is what, and then we can further pick one topic in future and then deep dive into each of the topic. Okay. So guys, the aim, and this is going to be really important because once you know the big picture, then pieces you can further explore also. Okay. So the aim of this today's session is you should get end-to-end overview of Spring AI. Okay, what are all these concepts and how Spring AI supports it? End-to-end clarity should come. Then later on, we can get into deep dive. Okay, so you should become comfortable with this documentation of Spring AI. Okay, with this documentation. And if you can see, Spring AI provides a lot of these features. Whatever these things are, we want to understand all of these things as part of today. Okay. Now, firstly, before we start, so guys, are we clear with this? Is it clear? What are we doing here? Can you give a quick thumbs up? Are we clear with this, guys? Okay, what exactly we want to do here? Are we clear with that? So it is going to be a one master session, which will act like a guidance for you to really understand what are these AI concepts and how Spring is offering it. So full details in one session. That's what we are trying to do here. We will not dig into any one of the topic in very great details. And we are not going to build a practical coding application today. We will understand end to end. That is the aim of today's session. Okay, fine, fine, very good. And it's very important because there are gaps in thinking for people, okay, where all these things fit. So this is a master session which will make you ready. Okay, so we will take again one poll by the end of today, and let's see how many of us are able to have this different. Okay, chalo, let's see. I will take a quick screenshot of this one. Okay, the current state of the poll. Let's open it in a paintbrush or somewhere. Let's open it in this place. Let's see, by the end of today's session, we will take another poll and let's check on your knowledge and confidence. Where do we lie? Okay. So this is the beginning state. Okay. Let's start with the topic. So firstly, please understand this basic thing. Why it is important to learn Spring AI and why almost it is like required, means it's not optional anymore. Why learn this Spring AI and AI engineering? What is AI engineering? Working with all these concepts and building an applications which supports all of these kind of capabilities, and new things will come in future. So how do you adapt to that? All that world is the AI engineering world, and Java guys are commonly going to use Spring AI to interact with these AI related world. Why is it important to understand? Please get this part clear, then it will become really easy for you. Currently, you build your Java application, right? You're writing, let's say, Spring Boot application or whatever application. This application needs to connect to a database. Yes or no? Right from beginning, core Java times itself, you learn JDBC programming to talk to your database, right? JDBC programming. As you grow and you learn that there is Spring JDBC, which is a framework to work with it. Then you will learn there is Spring Data JDBC also. Then you will learn there is Spring Data JPA also. And then you might know there is something called as Hibernate also. Now, point is, why do you learn all this? Because you want your Java application to talk to the database. And we know that without database, these projects cannot function in the industry. So everybody right at the beginning learns all that. Now you need to understand we are in a changing world where other external systems have come in picture, and these are nothing but AI systems. Okay, AI systems. What are these AI systems? We can call them AI models. Multiple models like LLMs, image models, video processing models, audio processing models. In the real world, now there are multiple these kind of models also coming. And your same Java application, we want should be connecting to now these models as well. And slowly it is going to get even more common. If you are hearing all these news right around Accenture, Infosys, and all these other big companies, they're all saying we will become AI first. Nothing but in every project that we do, we will think from the use cases of AI and try to introduce AI. And then they are saying all the application developers should learn and upgrade themselves into AI skills. What does that mean? You should become capable to work with AI based systems. And the way when you work with database, you have to learn a lot of things here. ORM style programming, JDBC or query style programming, how to create tables, how to write queries. There is a big learning curve when you do this. You need to understand when you work with these kind of AI systems, there is that big learning curve as well. You need to understand all of these things which come in the journey, which is nothing but what is this GenAI? What is this LLM? What is this VectorDB? What is this RAG? What are these tools? What is this memory? What is this context? What is this MCP? What is this AI agent? What is this workflow? What is this context window? What is this agentic framework? All these are basic things. What is this MCP? So these also are all terms which are being launched when a Java developer or any developer wants to work with an AI-based system. So it is important we understand all these things, and then we understand how to develop an application which does this. And you will realize very soon, many projects will start adapting to this. And that is where, if you see it in the news, they all say the market needs AI developers, but the Indian industry is slowly moving there. Not right talent is not fully ready. And that is where we have to upgrade ourselves. Like we see around in our today's poll, 96% members are new to these, and it is expected because these things are now coming in. So you are in the race. Okay, so all the members who are live right now, let's say this 117 members, I would like to tell you, there are lakhs of people who are still not aware, and after 3 hours they will still be not aware, but you will be different because you joined here, you want to upgrade, and you will upgrade. So already you will have an advantage. So along with your backend application skills, let's say Spring Boot related skills, now we need to understand even all of this. And today's session is designed specifically for this purpose. It is one session only. I'm not going to break it into like tomorrow or later. It is one session, and the aim is we cover everything. So listen to this part very carefully, because if you are not upgrading right now, you will still be part of the crowd who doesn't know all these and losing certain opportunities in the market, right? So along with your backend development, have these skills, add it onto your resume and hunt for jobs accordingly, because these things, lot of working professionals also do not know this. So I think you have a very strong, solid advantage here. Okay. Chalo, all those basic concepts, I think now you should realize why it is important to learn this. And let's start with our topic. Okay, let's go. First of all, basic terms, terminologies we will clarify. Then we will get into all the other features and capabilities. Firstly, in the year around 1950s, that duration itself, 1950 to 1960s, the term AI came for the first time, which is artificial intelligence. Basic concept, the way the human being thinks, learns, okay, makes decision. Now, can we make machine to also do the same? Okay, can machines also do that? Can machine, okay, learn, process, make decision? So a human being is not always required to do everything. We can hand it over to machines. That kind of basic concept came AI, artificial intelligence. And in order to achieve this, they created some software systems which are called as AI models. So in order to achieve this AI, there is the term which came in the market, AI models. Now, the Spring team has done a pretty good job in explaining all these things. Okay. So they created this nice kind of page. So we will keep referring to this because aim is we should understand all of this. Dekho, a basic thing, you should become self-sufficient to explore this document. So I'm not going to just spoon feed things to you. I'm going to explore it along with you, so you get confidence on each part of the documentation also. So it's not a teacher student wala, it's an exploration wala concept we will apply. So there is this kind of a link, AI concept. Okay. So first link, in the overview, we are starting with AI concepts. They have clearly defined some basic definitions required. We will keep referring to it, but they have officially just see what basically is a model. No need to get into too much technicality, but AI models are algorithms designed to process and generate information, often mimicking human cognitive functions. Nothing but the way human being can think, plan, make decisions, like that software should do, and that is what is called as a AI model. So that is a basic definition of what this AI model is around. Okay, and this has been there since long time. So machine learning related models, neural network related models, decade by decade, things have been evolving. Okay, until this year 2017, some big change happened which led to this era of Gen AI where we are currently available, like generative AI. Generative AI. Okay. So we are into this time of Gen AI. Okay. And what exactly is this generative AI? This is special form of AI models. So it is a subset of AI model itself, and the primary aim is they can generate new information. Means things which do not existed in the past, they can generate that. It could be new text, new images, new videos, which do not exist on the planet. The models became capable to develop that kind of thing. And Spring is such a kind of an ecosystem which is offering now us to build GenAI based applications also. And if you go back to the Spring related main website, spring.io is the main website. Now they are even publishing this kind of stuff. We can build generative AI applications using Spring ecosystem. Okay, integrate AI in your Spring application. Okay, and they are doing a lot of things behind the screen. So it is easy for a Spring developer to work with AI. And just observe, just read through this together. Generative AI. Businesses everywhere are looking to transform their application by adding Gen AI. Nothing but this first part. The businesses, projects are trying to go towards that area. Okay, and then there are certain use cases of that: chatbots, code assistants, healthcare diagnosis, blah blah blah. What is generative AI? Generative AI is a type of artificial intelligence that can create new content such as like this. So basic clarity should be there for everyone. What are AI models? What is this field of generative AI? Gen AI. It can generate new things which does not exist on the planet. And as you go further, things that make, and there are certain advantages of Gen AI, leave that part. Why Java developer should care? Because Java is popular for building enterprise application because of lot of reasons. However, integrating AI capabilities like RAGs, MCPs, and all these other terms that we said, okay, for that, just observe, people were earlier switching to different platforms like Python or some other programming. They were going there because Java did not provide a solid way to do that in Spring framework. So with this Spring AI, now even Java guys, okay, don't have to switch the platform. They can just do it here itself very easily. So that's where Spring AI comes in picture. And they have just defined some basic terms about Spring AI. It is robust Spring framework designed to empower Java developer. Okay. Spring AI is a robust extension of Spring framework. Means core Spring related concepts will be as it is. The people in the group who are aware of core Spring concepts: beans, containers, dependency injections, dependency lookups, auto wiring, auto configuration. Okay, when Spring Boot comes in picture, auto configuration, starters, all those things are going to be there. Okay, and it is designed to empower Java developer to create AI capable application. And you can easily do that if you are aware of Spring system already. Learning these new things will just be learning new classes, learning new methods, and yes, new AI concepts also. Okay, so for example, just have a look here. This is a simple code that you can invoke a AI based model. Simple code. What is it? If you are a Spring programmer, you already know this. Service will make it a Spring Bean. Here we are injecting using constructor injection ChatClient. Okay, this builder object will come from the container. Using that we can get it. Nothing but if you are aware of Spring, working with these AI based models is very easy. So you just got an object and you're calling some kind of methods and then achieving the results. For example, if you just write this kind of a statement, you're basically talking to a, let's say, LLM. I will officially launch what is an LLM, but let's say with a model, let's assume GenAI model. So using this, you're talking to a GenAI model, tell me a joke, and the model is going to respond back with a joke. So how much hard the code is? Nothing. Just injecting a class and working with it. So if you're already aware and comfortable with basics of Spring, working with these LLMs and AI models is fairly easy, but still new things you have to learn because all these are new concepts, where they fit, and then which classes of Spring is capable to do what. which methods to use, what are the best practices to use. Yes, there is a big learning curve coming with it. Okay, fine. So that is where Gen AI comes in picture. What I will do is I will keep adding these references in our notes. This is where our basic getting started stuff is. Okay. Next, these are the AI concepts. Next, this is a link about Gen AI related quick intro. Okay, fine. Now, moving further, what basically gave rise to these kind of models where it is now generating this? They go, three things happened, because from 1950 people are trying to get, in 2017 they basically started further more drastic changes, and now we are in 2025 where big time changes are there. Already AI is now 3 years old where people are using it, and now it is evolving year by year with more and more changes. But basically three things happened till this point which added to this change. One is what led to Gen AI. What led to Gen AI? Why this was done recently? Okay, the primary main thing is the algorithms and architecture. Okay, nothing but by this time, neural networks, this is used internally when we are building with Gen AI models. Neural networks was already 10 years old. So a lot of grip was there in the market about neural networks. However, in the year 2017, Google launched a paper saying attention is all you need, which introduced a new architectural style called as transformer. And this basically changed the revolution of this Gen AI. So Google launched it. They did a lot of experiments. In this paper, they released attention is all you need. And they launched a transformer architecture. Later on, OpenAI company, the company who has developed this ChatGPT, they really took it very seriously, implemented it, and that is where the world saw for the first time the power of Gen AI. So these kind of models and other things are there since many decades. But recently, the world saw it for the first time when these guys brought into the market. And after that, more and more new companies have come in picture. For example, Anthropic is there. Anthropic, they have launched Claude. Then Google, they have launched Gemini. Okay. And there is a lot of other things like, for example, Meta, they have launched Llama. And then there is this DeepSeek, which has whose model is also kind of DeepSeek itself. So in the market, many companies came in picture and they started launching their own Gen AI. But the transition happened something like this. And what made this Gen AI possible is majorly two things. Architectural and this algorithms and architectures were really very solid for this point. The second thing which happened here was huge amount of data. Okay, the world is now massively digital. There is tremendous amount of data publicly available in blogs, posts, this, that, huge amount of data. And the third thing is high processing power. High processing power, CPUs like GPUs, graphic processing unit, and even TPUs, tensor processing unit. Okay, so these are some things designed for very heavy processing. These came in the market. Huge amount of data is now globally available, and then the algorithms were also very smart, architectures were defined. A combination of these three led to building a Gen AI related world. You need to be aware of these basics from where all this revolution has started. That is where these clarity should be there. Now, there is a next topic. There are different types of Gen AI models. Types of Gen AI models. Okay. And in the Spring documentation, these guys have again explained those Gen AI model types also. Just have a look here. Gen AI models can be called as LLMs, large language models, or even image generation models, text to voice models, voice to text models, embedding models, vision based models. So there are several types of Gen AI models. Okay. So that is the next thing we need to understand. LLM is one of the type of GenAI model called as large language model. And there are several other, like you can see, which is mentioned in this link here itself. Okay. So different model has different purpose. One of the most common use case where our applications need this AI capability is with this LLM model. That is the most common use case where majority of the projects are preferring to use GenAI right now. The use cases where image, voice, video is required, there you might use that. But for majority of the projects of the world, they need the capability of these GenAI models in the form of LLMs, large language model. That is where it comes in picture. Okay, so LLM is the common use case which majority of projects need. If you need image, video, then you have to work with those models. But majorly, LLM is being used. Majority of the cases, projects will need LLM kind of working. Okay, what is this LLM? Okay, basically the term says large language model. We will understand the term later. For now, understand this concept. LLM basically, when it came for the first time, its basic aim is take the input and input as text and give the output as text. Okay, nothing but when you go to something like this ChatGPT, right? So ChatGPT is basically built behind some kind of LLM itself, right? So when you say, how are you doing? So that is what is nothing but an LLM. You give it input a text, behind the screen, LLM is running, which is a large language model. It understands what I am saying and responds back to me. This simple concept itself is LLM, large language model. Using that model, we can achieve this. When we ask, okay, hey, generate an image. So what they did is, if you remember the beginning days of all these AI revolutions, LLMs was designed to process text only. However, as the world evolved, now it can even process images, audio, and videos. So gradually, it is going into all those areas. And that is where LLMs are further upgraded now. Earlier, it was only for text processing. It can input text, output text. Now they are making the LLMs as multi-model LLMs. Multi-model means they can deal with other kind of data also, and that is what you can see in this diagram. Earlier it started with language, nothing but text form, or code is also a language, you can type text there. But it started becoming multi-model, where same large language models even started consuming images, audios, videos, and even in the output to generate different kind of things. So are you getting it? Gen AI is the primary thing where it generates new things. It can generate images, text, okay, language or audios, and different kinds of output. LLM earlier came, okay, input will be text, output is going to be text. But as the time progressed, LLMs upgraded and became multi-model LLMs, which can take multiple inputs and can give multiple outputs. Okay, guys, one thing, can I suggest you one thing, everybody? Open up your notepad and at least whatever new terminology you are listening, write it down in your notepad. That will at least have something to you in the end. So I will give you the recording of this today's session also, but I would suggest कि एक notepad खोल के at least write down the main things so that you don't, no need to write definitions, recording will be there, but at least the main terminologies, can you write that? Everybody, please open up your notepad, and once you have your notepad written in front of you, give a quick thumbs up. At least for now, write this term, what is AI, what is AI model, just the name, no need of writing description, and what is this Gen AI. At least the terms, write it down on your paper, and then types of Gen AI. and then launch LLM, and then say multi-model LLM. Guys, at least write down these words in your notepad. Then you will have something with you. And once you're done with this, please give a quick thumbs up. Write it down. Don't take screenshot. Arey, shortcut, where is shortcut, man? Write it down. Okay. And once you have it, please give a quick thumbs up so we can continue with the next point. Just the terms. So later you can think about it. But yeah, there is clarity is required in all these basic concepts. Okay, some of the guys are already done. Very good. Everybody do this. Don't just take it as theory, ke aaya gaya. Nothing will happen with that. This will shape your career. So I don't want to make it short, like 1 hour or 30-minute session and like in that summarize it. No, it is going to build your career for the next 5 years. So let's invest time into this and try to really understand it, right? So shortcut nahi lete. These are beginning building blocks. Do involved learning along with me. Okay? Chalo, very good. Fine. Let's continue, guys. Thanks for confirmation. Let's continue. Okay. So that is where write down the terms, please. Write down the terms. Don't just keep listening. So here we are, where LLMs are there in picture. Multi-model LLMs are there in picture. Okay. Now that means if you go back to our diagram, we need to build a project. Okay. So we need to build a project which can interact with these kind of LLMs. You can imagine. We need to build a project which can interact with these kind of LLMs. Let me take a screenshot and let's put it here. Depending upon your requirement. Okay. So let's say this is your Spring Boot application. And this Spring Boot application should be able to talk with these kind of systems and get a response like this. And this Spring Boot application, which we are going to develop, for this itself, we call it as AI applications. So the applications which is working with AI is called as AI applications. Okay. Or people might say AI powered applications. Or in this logic itself, we are getting into some type of logic which we have started calling as AI agents. A certain type of logics we have started calling AI agents. There is another type of logic which we call it as the workflow LLMs. So all this is nothing but when we are developing our system, we use different kind of styles of programming, and this is AI application or AI powered application, or further becoming AI agents, workflow related systems, and which basically just interact with GenAI models which is available in the real world. So we need to get this context also right properly. Okay, fine. Now let's just imagine what exactly this is. So we need to break down one fact here. What is ChatGPT? Okay. So what is ChatGPT? Let's get some basic clarity about this one. ChatGPT is nothing but it is one application. The way we can create a Spring Boot application, AI application, right? Now, like that, ChatGPT is also one application, kind of a web application. Maybe having multiple microservices behind the screen, whatever their model is. And behind the screen, it talks to one of the LLM. And the LLM which ChatGPT talks to is GPT. GPT, Generative Pre-trained Transformer. Okay, Generative Pre-trained Transformer. This is the model name for this guy. That is where when you go to these kind of chat GPTs, okay, and it is saying GPT-5, nothing but this is the model which is being utilized. Generative Pre-trained Transformer, and the version number is 5. So what do you understand by this? The model that we have, when we use ChatGPT, basically it's two systems. One is a application, the way we used to develop an application. Like that, ChatGPT is an application which behind the screen works with the LLM model, which is called as GPT. Okay, so we can simply say GPT is the LLM model given by OpenAI, okay, and which we work with. And accordingly, this Claude is the LLM model given by, okay, Anthropic company, and like that, Meta LLM, they gave their own LLM models. So we need to get this clarity also. So ChatGPT is nothing but an application. Here there is lot of additional logic. So when we use something like this, we work with ChatGPT. So here is the end user. End user works with the ChatGPT. A lot of logic they do, but behind the screen, they talk to GPT, which is their LLM model. This GPT is given as their LLM model. So we need to understand this. And the way this kind of application talks to them, accordingly, situation comes like we also need to build an application which can talk to the core models. Okay, so when they can build it, when so many companies are building it, and that is where Spring in the documentation they said, right, one of the use cases of GenAI is conversational chatbots. Nothing but these guys are building conversational chatbots itself. One type of application. Now, as the projects grow in the real world, our business logic will need that we interact with a lot of other models also. So we need to understand the breakdown. Okay, what is GPT and what is ChatGPT, right? We work with this and like this. Similarly, our expectation is there in future. Our end customers will work with our application, and we are supposed to further work with these guys. Okay, fine. Now, moving to the next point. There are so many types of models in the world, right? How is Spring AI providing you capability? There are so many models in the world. It is just evolving. Okay, what kind of capability is Spring AI offering? So let's go back to this documentation of Spring. AI concepts is there. Let's go to this field. And what do we see here? Just see in the references, there is something called as model. And if you open that, there is chat model, embedding model, image model, audio, and moderation model. Means they have categorized the models which they are integrating. If you expand the chat model, they are saying what kind of chat models Spring AI is supporting. You can observe here, Open AI related models it is supporting, Olama related models it is supporting, Hugging Face related models it is supporting, Grok related model it is supporting, okay, DeepSeek model it is supporting, Amazon related models it is supporting, Mistral AI, Moonshot AI, Nvidia related models it is supporting, Perplexity it is supporting. So just observe the popular models which are available in the world. Spring AI tried to provide support for that. And not just into the chat related category. What is chat related? LLMs. Chat model means LLM. You can talk to it, ask a question, gives back a response. So these are some of the chat related models available. You can integrate with this guy, Spring AI. Likewise, if you want to integrate with other models like embedding models, let's not get into the details of all the other models. We will keep our focus to the point so we get maximum value. But yes, there are different other type of models also. Different companies has given embedding models. Spring provides support for these kind of embedding models also. Image models, so there are around 5 kind of image model support which is provided by Spring AI. And then audio models, there are some text to speech related. So as you can see, for other categories, few of the model integration is there, whichever is more common or more popular use cases. And that is what Spring version by version will upgrade. So this is not the end of it. Every release, they might upgrade new AI concepts, new features, new capability, new model support. They will keep doing it. So right now we are at the version 1 itself. Let the time pass by. More and more capability will keep adding to this Spring AI ecosystem. But the point to be understood is Spring AI has categorized models as chat embedding image audio moderation. So we can just take a note about here. Spring AI has categorized all models as chat model, embedding model, image, audio, moderation. Now you can explore each of it, but basically this chat related model is talking about LLMs. And we said this is the primary use case of the current world working with LLMs. This is the primary use case. Okay, fine. Okay. So guys, let's do a quick understanding score. Okay. So let's take understanding score. Whatever we discussed so far, are you catching up with the topic? Then we will go to the next one. Okay. What is your current understanding score? If everything is clear to you, mark a 5 or a 4 and 3 and 2. Please mark it. Please mark this poll, guys. And देखो guys, whether the things are easy, whether the things are tough, point is we have to understand it. And so far we are just beginning. Okay, we have not even started with the depth of topic. One by one we will keep discussing. So be focused. Okay. Chalo guys, vote it. Roughly around 19 members, 20 members voted. Yes, these terminologies might be new. So adapting it for the first time might be a bit like, oh, everything is coming new. But watch the session again. Take some notes at your side. Prepare on those topics. In order for me to have this kind of discussion with you, it was not just only today or yesterday I prepared. I've been doing this kind of research now since many weeks or even more than a month, and then explored, understood, and then these words started coming, settling into the mind. And that is where now I am able to share it with you. So it needs a lot of efforts behind the screen. You need to put that kind of effort. Just listening it for the first time, something will come, something will be lost itself. But try to understand it, because the world is heading in this direction. If you also don't move, you will become outdated. So you need to get into this AI related times of swing. Okay, fine. Chalo, let's get started. We see roughly around 50 members have marked the vote, and we see majorities are 5s and 4s. There are still guys with 3s and 2s. Work more hard and belong into 5s and 4s, everyone. Okay, let's continue further. Let's continue further. So as we start deep diving, what we realized, multiple chat models are available. Now, there are a lot of features for these models. So let me first copy this chat models. Inside that, this chat models available. There is this page which they have given. What are the capabilities of these multiple models? So they have done a comparison. Which kind of models is multimodular? Tools, streaming, retry, observability, built-in JSON, can be run in local or compatible with open API. Nothing but some analysis. So now we need to understand models might have different capabilities. These capabilities are nothing but some of the features what the model can actually offer, and different models can do different things. Spring team has updated it here, but we need to be aware over a period of time multiple models will start offering these features also. So we need to be aware if this documentation gets a bit old, if Spring has not always kept it up to date. So latest things you can find from internet by searching. But please put another point here. Spring team has done some analysis of these models, did some comparison, and tried to do which models actually support what kind of work. That is the point to be noted here. Okay? So chat model comparison. Model comparison. Which model supports what? Okay. Next, you can find that comparison here, and please be aware it can keep changing also. Second thing, you need to be aware of this. Okay, these are not just direct models. Let's say when you click OpenAI. Okay, so working with OpenAI, so all the models of OpenAI, GPT-5, GPT-4, and multiple other models, if you want to work with that, Spring has provided a step-by-step documentation for it. Let's say in your Spring Boot application, you want to work with OpenAI. Okay, in this documentation, they're specifying how to do that. What kind of value should be there in your property file? What kind of configurations are basically required? Which dependency should be there in your POM file? And then so on. What parameters are required in your property file? So everything is specified here. Okay, let's say you're working. So using this kind of parameter, you can say which model you want to work with of ChatGPT. Okay, for example, do you want to use GPT-4o, GPT-4o mini, GPT-4 turbo, GPT 3.5 turbo? So GPT team has given names of every model which they are launching, or OpenAI, they gave names for every model which they are launching. Using this kind of configuration, you can work with it. The point that I'm trying to make here is, in this documentation, they explained how you can integrate this model in your Spring application. Which parameters should be there, which configuration should be there, some meanings of that, some code samples of that, how you can do all of these things. So they have put some effort so that people get started talking about some capabilities. They have done that kind of work. Even supporting multi-model capability, you can give an image, ask it what exactly it is. So whatever capability given by OpenAI, they have tried to provide that kind of thing, how to get the audio back. So next aim will be, whenever you want to integrate with any model, go to this documentation and read it from top to bottom. Because multiple, if you want to do audio, output as audio, how your code should be, code snippet of that, everything is there. Explanation of that, everything is there. You want structured output, how to make that, everything is available. Now, just spend some time. They have given some nice amount of code snippets, audio working snippet, image working related snippets, and then chat working vision related snippets. So whatever features OpenAI is providing, Spring has tried to integrate it and telling you how you can implement that in your project. So the next point you should understand is, for integrating any model, just go to that model description. There are sample examples, explanations. You have to do some exploring, finding, and then apply those features in your project. So that is the next point to be understood. Okay. For working with any models, you need to explore their integration link. Okay. All features, capabilities, code snippet, it's all available there. Okay, code snippets, it's all available there. Okay, fine. Chalo, moving on. Another point you should know about this section is that these are not just company offering their models. As the world has evolved, there are a lot of platforms. Multiple platforms have emerged. Okay, for example, currently we are saying, fine, your application will talk to, let's say, ChatGPT related GPT LLM. Okay, so let's say this is a GPT LLM, which is given by OpenAI. So OpenAI is the company which has given GPT LLM. And your application wants to talk to this. Few things you need to understand. Almost majority of the models is simply exposing REST API for this integration. REST APIs. In order to talk to this model for doing certain actions, they have given REST API. So using REST API, your application can talk to, let's say, GPT LLM given by OpenAI company. So this is one form where the companies are directly providing their models, you can use it. But as the world is growing, there are a lot of platform providers which has come in picture. Okay, platform providers. Nothing but these are single places where multiple models are available. Okay, for example, Amazon Bedrock. Amazon Bedrock. So this is a nice place where you can find different types of models by different companies, and you can choose anyone and work with it. So you don't have to directly integrate with only one company and work with their model. You can go to them via other way also. So this kind of systems have also come in the market already, where there are platform providers which is offering multiple types of models. Okay, multiple models of different companies are also available. One of the provider is Amazon Bedrock. Using that, you can get it. Next, Azure is also providing it. GCP, Google is also providing it. Next, there are certain other platforms like this called as NVIDIA. Okay, for example, if you go here to the NVIDIA related section, they have given some nice diagram also. Your Spring AI application can talk with the NVIDIA, and there are multiple different models can be given here. Databricks, Google, IBM, Microsoft, Mistral. Okay, model given by NVIDIA also. But try to understand, this now becomes a platform provider. So you just don't talk with only one company's model, rather many options are there. Whichever one you want to use, you can use that. Like that, there are all these other guys also. Amazon Bedrock can do that for you. Next, even these kind of guys, Hugging Face, there multiple types of models are there. You can talk with that. Even Olama, these are other names where multiple types of models can exist. Okay, Olama, Hugging Face. So these are multiple platforms where different types of models can be available, and your application can talk with them. So this thing you need to be aware of. Take this example so that it makes it a bit more clear to you based upon Spring documentation part itself. Okay, like this. Fine. Now comes the next question. How is Spring allowing this integration? How is Spring allowing these kinds of integration? That's the next question. So guys, in your notepad, you should have written this word. Okay, multiple platform providers are there. Platform providers are there which can host multiple LLMs. This thing should be there in your notes also. This thing should be there. Okay, you can refer to the link, and all the integration details of that model is available in that link. It should be there in your notepad also. At least the term should be there, so you have some takeaway, so you can research all the individual points which we are discussing. Okay, fine. Let's continue. 1 hour is done of the session. The base foundation is laid. The terminologies are being laid. Now we will get into more technical part. So stay focused. Okay, fine. Now comes the next thing. How is Spring allowing these kind of integrations? Now just imagine, in the real world, like we said, this is our Spring application. And there could be different models, companies, or there could be different platform providers, which is internally hosting these kind of models. Okay. Now, Spring application should be able to talk to all of these different pieces. How to do that? Okay, what Spring team has done is they have done coding at their side. We said they are all REST APIs. Majority everybody is REST API. Some guys do socket-based, web socket-based integrations also. But Spring team has done that. Okay, for example, if they want to talk to OpenAI, they have created internally some class called as OpenAI Chat Model, where they have written all the code to work with OpenAI. Next, they created another class called as, let's say, Olama Chat Model. The names could be here and there, but basically approach is they might have created this, and using this, they are trying to talk to this one. So multiple Java classes will exist in your project. And now try to imagine if you add the Spring Boot dependency of OpenAI, automatically Spring Boot auto configuration will create an object. Those guys who are aware of framework and Spring Boot, I'm talking to you guys now. Just that, the way these guys have said, right? OpenAI, they mentioned here, okay, simply go ahead adding this kind of a starter. As soon as you add this kind of starter behind the screen, these objects will be auto-configured and available in your container, which your Spring code can use for making the further work with LLMs. So what do we conclude from this? Okay, when we add jar files or POM of multiple models, then the corresponding beans are auto configured and available in container. So those guys who are not aware of framework, Spring and Spring Boot, so let's skip this wala point, okay, because you are not aware, so you will be confused here. So let's skip it. Let's move to the next point after that. But for all the other guys who have basics of framework, you need to understand when we add the jar file, then in the internal, they created multiple Java classes where they have already written the code to talk to these people. So we don't have to write it from scratch. We don't have to directly understand their APIs also. And that is what Spring Boot was saying. Okay, we have done some simplification for you. You don't need to extensively reskill also. Just work with our basic things and it will work for you. That's what Spring guys is trying to tell us. Okay, fine. Coming back to our next point. When we add this jar file, it is going to do that. Now, just imagine. Here again, thinking is required. Just imagine. If let's say you want to work with OpenAI, with GPT model, or you want to work with Claude related model or Hugging Face related model, just imagine in your code, guys, the core Java basics mein I'm going here. That's where we said this is for Java developer. So let's say you want to work with this class, it will have certain method. So what you will do, you will import that class. We know how to import a class in core Java basics, right? Imports package and then the class. Then you will create an object of this and then call object dot whatever method. Now just imagine tomorrow in your project, you want to integrate with this guy, Olama chat model. Then you have to import that. You need to understand what methods that is defined there. So please note that every time, every new integration could have been very painful for Java developer. So Spring said, no, 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 we don't want to give any pain to the Java developer. Please understand this point, very critical. If you directly work with these objects, you have a big learning curve. You need to study these objects, check what methods coming from here, what methods coming from here, and then use it. No, Spring has standardized that. They created one common interface called as ChatModel. And all these classes simply implement that one. So in this, they have defined standard method names. Let's say call something. So what will happen? You just need to know what contracts are available in this chat model itself. So you are not required as a Java developer to keep studying all of these classes and what complexities is there. No need to worry. You simply work with the interface level itself, chat model, and call the call method. Internally, their objects will take care of all complexity for you. That's how, with this chat model interface, Spring AI team has simplified your application development. So currently you are working with OpenAI. Let's say tomorrow you want to work with Claude related model by Anthropic. No problem. You can just switch it without any code changes. Okay. If you want to go ahead working with, let's say, a DeepSeek related model, your Java code will not change, only the jar you change in the class path. So the point here is you will code with regards to interfaces. So everything will be done in a standard manner. You don't have to learn each of these internal implementations. That is where life of Java developer is simplified. So what do we learn from here? Okay. Instead of working directly with model integration classes, we can work with the interface chat model and via standard way of communicating with any LLM model. Okay, that we can do. Now, in the Spring related documentation, just observe, they have provided some nice view of this. We can check it out here. I'm clicking on chat model. Okay, let's click on the models section. Just observe this diagram. This diagram will give you further clarity. This is how internally they have done. For all the model providers, they created their implementation classes. And then they created this kind of an interface called as chat model. So core Java, interface and implementation, whatever methods they have defined here, they all have to write the code of that method. So as a Java developer, if you just get this interface, call this call method, and behind the screen, whatever child object you use, it should work. So it's a proper modular system which they created. Just take a minute to absorb this. Okay. And just observe, they have this further thing also. This chat model implements model. So they have created much more architecture here. Model is the primary. Under that, chat model is there, embedding model is there, image model is there, speech model is there. So nothing but how the Java objects are arranged. That's what we are just looking here. So that is where you can see model is the top. Under that, chat is there, embedding is there. And then using this internally, they created so many child classes of that. So you just have to work with this layer and you will be able to achieve big capability using chat model. This is how they have evolved. And if you go to this documentation itself, go to click on this chat model. They have given multiple examples how to work with chat models, what kind of methods are available, everything with code snippets. Furthermore, details about everything you can find here. How to work with chat model, they explained everything in detail. If you want to use it directly in your project, all the explanation is there. Which interfaces, which methods, how they are linked together. So proper diagrams, code snippets, it is all available in chat model URL. That's what we can see here. Okay, that's what we said today. We will understand the full picture of Spring AI. So using chat model, you can work with it. Okay, but then what happened? If you are aware of the recent few releases of Spring, Spring is encouraging to use Fluent API. Okay, Spring is encouraging. Now let's say guys, some of you guys are, let's say, very freshers. You are not able to fully capture all these object structures and everything. No problem. At least get it at a high level. Okay, they have arranged some interfaces, some child classes in a very organized manner so that developer life is simple. At least just understand that part. Okay, so internally there is a lot of things, but yeah, for developers they have made it simple, but internally they are doing a lot of work. So yeah, framework guys they have put in a lot of efforts there. Please understand that. Okay, fine. Now moving on. Listen this with focus. One by one, we are getting into depth, and we have to discuss all of these big topics also. One by one, we will reach to that. Okay, let's come back to our point. So in chat model, they have given. But recently, Spring is encouraging to use Fluent API. What is Fluent API? The way we talk with each other. Fluent means easily you should be able to talk and communicate with one another. Spring is encouraging. Spring is encouraging to use Fluent API. Recently, they are doing that. For example, if you go to this REST client, just one another class given by the Spring system. What they say here, which is a Fluent API. Fluent API. This is modern wala. If you click here, just try to understand. REST client offers more modern API for synchronous communication. So you just need to understand Spring is encouraging to go ahead with Fluent API, and recent developments, they are doing it as per Fluent API style. Fluent API style is, it should be more easy for developers to use. That is Fluent API. Okay, the names more easy for usage. Nothing but names of the method should be easy. And they are doing one concept called as method chaining. For example, if you go to this Spring related main documentation, this is Fluent API. So on one object, you're calling a method. Method is going to return a value, but you're not saving it and all. You're doing a further method chaining. Whatever prompt returns, on that you're calling user. Whatever this returns, on that you're calling call, content. And just see, if you read this, it is very much easy to understand okay, what you are doing. Nothing but some prompt you are setting where user details, you are saying, tell me a joke, and you are going to call an LLM and you are going to get the content. This is Fluent API. Okay, in your coding, it should be very easy to understand what it is there. So this concept is Fluent API concept, and Spring is encouraging to use this concept. Okay, Spring is encouraging to use Fluent API. So what they have done is, just observe in the same diagram. Observe in the same diagram. If you go to model, on top of this full diagram, so if you want, you can work with chat model, but they have given a more easier way via ChatClient. So Spring is even recommending, okay, if you want to work with any AI models, go ahead using ChatClient. It is developed as per Fluent API concept, which is more easy for the developers to use. And using this, it basically internally will call the chat model itself, and almost all capability you can get it here only. So if you are doing a coding on your Spring Boot application using Spring AI, you need to work with ChatClient library, not required to work with chat model. Let's say something is not possible to do with ChatClient, then you go to chat model. But hardly, you will never need to work with these core APIs. You will always deal with the wrappers. So the first thing to go for is ChatClient, and mostly this itself will do everything for you. If worst case you're not able to get something done, then move to the chat model. So that one every developer should understand. Okay, so ChatClient is the recommended library, and in the first page they gave example of ChatClient itself. Using this, you can make a call to LLM. Okay, fine, let's make a note of this. Okay, so using ChatClient, Spring is recommending to use ChatClient, okay, for more ease of usage. Okay, ease of usage for the developer. And in the diagram, you can read through that. I will still again paste it here. Okay, and in some other part of the documentation, they explained about this chat client. Just observe. Here they explained it. So under model, chat model, they explained about the model APIs, but they created a separate first drop down itself here where they are saying chat client. And now in the chat client, again, there are all examples, how to use, how to get it done, how to call it, and multiple scenarios they have taken. In this scenario, you can use like this code. In this scenario, you can have multiple. If you want to work with OpenAI as well as Anthropic models, how exactly to create chat clients for them. So depending upon the need of your project, they have given multiple examples how to use this. So one by one, read this topic, try to understand how to use ChatClient API. But just see, they have given, and ChatClient is a Fluent API. That is what they have given. Fine. So we need to read it from this place, ChatClient. Okay. So all examples of how to use, what methods are available, they explained there. Okay. So ChatClient section is clear. Fine. Okay, guys, let's put one more time understanding score, and then I will take a minute to summarize it once more, and then we will go to the next topic. Yes, some of these things might be new, and if you're a beginner, it might be challenging also for some of you guys. Okay, but you need to understand the world is heading into AI, and we need to learn these things quickly and adapt so that we are really relevant. That is where we are doing this topic. So put efforts to really grasp it. Okay, and Java guys are now coming in, so you have to really be faster here. Please share your understanding score. Chalo guys, 5, 4, 3, 2. Okay guys, please mark this. And because it is hard, that is where it is good for you, because others cannot learn hard things. If you put efforts, you will always have better advantage than other people. Okay, some of the things will be hard to catch, but that is where is a good opportunity for you to grow faster, right? Easy raha to the entire world will quickly adapt. So you need to take advantage of, because it is hard, work double hard. That is how you can get it soon, right? Simple. If you put efforts, it is easy. Others will feel, no, it's very complex. No, for you, it is easy. Put efforts. So 26 members have voted so far. Okay, we can see there are good amount with 5s and 4s. That is awesome. Let me quickly summarize the point, and then we will go ahead. Guys, everybody, please focus. What we are speaking about. In the real world, multiple models are available. Okay. In the real world, multiple models are available. We want that our application should be able to talk to these models. Either we can directly talk to them, or we can talk to them via multiple platforms. What Spring team has done is, Spring team has provided us multiple Java classes where they wrote the code to talk with these multiple providers. Okay. Now, to make our life simple, they abstracted so we can directly work with chat model. Furthermore, they are saying, even I want to further simplify it for you. So don't use chat model, use chat client. Use chat client. And then using chat client, we can integrate with any kind of a LLM models. So chat client is for chatting related purpose. So accordingly, we can achieve it. Okay? They have given some multi-modularity support also, one like image and other things you can do. But yes, primarily we are discussing it perspective of chatting related application. Okay, fine. This is what was the story. Use chat client to call LLM. That's it. That's the whole story in one line. Use chat client to call an external LLM, and it will work for you. Awesome. Now you need to understand some more technicality here. When this call happens, let's say this is your system, guys. Everybody, please focus. Let's say this is your system, and this right hand side is the LLM. So this is LLM. OpenAI company has given the name of the LLM as GPT. So let's take that example. Now, here they have certain business logic, and we are saying they exposed an API, a REST API, which needs to be called. Fine. What is going to happen? This is your Spring Boot application. You have done the coding of Spring Boot application. How the flow will happen? Step number one, when the end user requests for certain kind of information, internally you will write your REST API. You have learned REST APIs, how to develop that in Spring Boot. It will come to a place and code will start executing. Code will start executing. A point will come in the code where you will define, now I need to make a call to this external LLM system. The way you work with the database, right? Your code is executing. There you make a DB call. You get the result, you continue. Similarly, we have to work with now LLM, a different kind of external source. So whenever a request comes, you are running the logic. You speak to an external LLM now. They will apply artificial intelligence and all the human intelligence kind of stuff there artificially. And then they are going to respond back. The LLMs will be responding back. Once the response comes, you will continue with processing. So this is the basic flow. Now, we discussed the primary class required to do this action is ChatClient. Okay. Now, basic terms you already know. Okay, when you are using, let's say, ChatGPT, when I asked, how are you? We all know that this is called as prompt. So we write a prompt, then this ChatGPT sends a request to its GPT model, it processes a response, and then tells back here, I am doing good, thanks for asking, and something, something. So some terminologies are coming here that before we send the request, we need to work with something called as prompt, which will have your message. And then we will make some call here. And then response is going to come, and then we will process it. So you need to understand now, along with ChatClient library, they gave some other Java classes also, like PromptTemplate, template, message. These kind of Java classes are being utilized even while making the call, whatever data preparation. So please be aware, ChatClient is the primary one, but internally, whenever a user is saying, let's say, how are you? Let's say end user makes this kind of a request to you, how are you? So in order to properly capture this request and send it to LLM, you need to work with other Java classes also, like PromptTemplate, and messages. That's the next topic you need to understand. And here, if you go, they have explained those things also. Just see in the prompt related section, they explained how you can create your prompts using Spring AI. Again, code for that is available. What is the prompt class looking like? It is having something called as message class. What is a message class which they are using? Everything is predefined. You have to create objects of these classes and use it in your code. So they gave very nice documentation okay, how to work with Spring AI. Very clear-cut examples. So they are specifying how the message looks like internally. This is all classes which they have created. But the point here is all these things are there. I'm not getting into roles part right now. It is next level. So let's leave it. But PromptTemplate, along with examples of how to use this while making a API call, everything is clearly explained. Okay, so you should spend some time in reading even this prompt section. Okay, so what is our next understanding, guys? In order to send the request to LLM, we need to use some prompts, some messages. For that also, Java classes are given by Spring AI. We need to create the right objects and use the right objects. That is what is this point. Okay, so let us write down working with prompt or PromptTemplate. Okay, while sending request to LLM, we need to work with these predefined Java classes given by Spring AI, and that is where these names are available. Okay, prompt template, message, spend some time there with nice examples and details. They have specified how to work with this. Okay, that is one. Second thing you need to understand here. So we said working with LLM is prepare the prompt, make the call, this guy processes the intelligence, returns the response, and you process the response. There is one part during response processing also, which is nothing but LLM by default is going to give you string. LLM ka return type is going to give string. But when you are doing Java based programming, that string needs to be converted. Let's say LLM gave a response as some int value, and you want to process based upon int value. So we might need Java object, we might need a list, we might need a map, we might need some JSON representation. So you can imagine LLM is returning back string. LLM is returning back string, but in order to write your business logic, you need Java objects, other kind of data structures. This is the second situation which is common for the project. LLM, the way when you type here to LLM, it gives us string only. Now just think, if your Java application is calling, it gives back string. We need to now process on top of that. So it is a very common use case for our project. We might need a Java object with multiple fields. We might need a list of something, map of something, or a JSON structure of something. How to make this possible? That is where comes the next concept of Spring AI, called as what? Structured output. Okay, Spring AI is providing a mechanism. Okay, they will take the string from LLM, convert it into a Java structure, and give it to you so that you can use it. Guys, similar concept is there, right? When you make a REST API call, guys, what happens? Let's go back to our traditional application development. You're writing a REST API call. In the input, you are going to pass a JSON. It needs to be converted into a Java object, right? Spring Boot is automatically doing that or not, using Jackson library. So automatic conversion is happening, string to your required objects. Similar situation here is also coming. They are returning back string, but LLMs are crazy. They can return us n number of things. So it needs proper processing. It needs to be done properly. So it is a big accomplishment even to do structured output converter. Nothing but output should be structured. So they have defined some converters which will read from response from LLM, convert it into Java objects. And how it works is, just observe this diagram. It will become clear for you. What is this? The end user is passing a raw input before calling the LLM. Before calling the LLM, using this structured output, you will add some other instructions. Nothing but what kind of format should LLM return back to you? Spring AI is going to do that for you if you use the right Java classes. So what is happening? As an end user, we are simply asking a question, how are you doing? Now, Spring AI, along with passing the request to LLM, it will add information saying, I need a list of string back, list of JSON back, or a map back. And that JSON is going to have these fields. Nothing but instructions are going to be provided to LLM, how the response should be formatted. So input plus the format instruction is given to the LLM. LLM is going to give the raw text only. Now, but because they asked for a specific format, LLM will respond back in that format, and then these converters will convert it to your required Java object, which can be whatever you're trying to do. Okay, so please read this part carefully. You will get the context. The ability of LLM to produce structured output is important for your application because you need proper values. Developers want to quickly turn results from AI model into multiple data types like JSON, XMLs, Java class, so that you can pass it in multiple functions, methods, and do the further work. So please be aware. These guys have given structured output capability also. So some converter classes are there. How to use that? They have given some examples of that also. Okay, they have given some examples how to use these formatters. Multiple converters available. Just see, you want a map based output from LLM, or just a Java object you want, or a list of object you want. You can work with these kind of predefined converters. Okay, everything is defined here. So documentation is really good, guys, with examples, what you want to use, how you want to use. So one of the requests that I'll make to you people is read the documentation. Read the documentation, spend some time, maybe by today itself, go through all of these sections just to understand. That will seal the knowledge properly in your mind. So structured output converter is the next concept. Giving the response in a proper format, not just a string. And yeah, this is how these guys have made it available. Okay, structured output converter, not as string, but as certain value. And if you are aware, in Spring AI concepts, they have created this one AI concept page where they are easily in one paragraph explaining. So a developer can quickly understand Spring AI. So first they explain model here. Next, they explained prompt related stuff here. Next, prompt template related. So you should definitely read these AI concepts in one page, one paragraph. They explained you all these things in one paragraph itself, right? So model related overview, prompt related overview, prompt template related overview. Okay, embedding, for now leave it. I took a 4 hours session last month where we discussed LLM internals. There we discussed this in very details. We will share that recording link if you are interested to know how the internal of LLM works. There we discussed embedding. So for now, let's ignore that part. Token is also discussed as part of that. And then structured output is what we are discussing right now. Okay, so that is the next topic. So what do we understand from this diagram? When trying to make a call, yes, ChatClient we will use, but other Java objects might also be required, like prompt template, messages. Then you call, you get a response. You might have to convert string into a proper Java objects so that you can use it in project, which is nothing but structured output converter. Okay, chalo, this concept is done. Moving to next concept. Write down in your notepad also, guys, structured output converter. Write down in your notepad, prompt template. So chat client should be written, prompt template should be written, structured output converter should be written. Guys, are you really typing the notes with you? Give a quick thumbs up if you are typing the notes. All the guys who are typing the notes, give a quick thumbs up. Let's see. Because generally, you will be like, anyways, Tausif is going to give me recordings now. Why should I write it? So anybody who is writing it, can you give a thumbs up? I will share the recordings. I will share the notes also. But that does not matter. If you have put efforts, you will remember things. If everything is ready-made, all this information is available on internet. I did the hard work to understand all of this and then share it. If you want it, you need to put that hard work. So at least if we have doing this session, put your hard work, then you will gain the concept. That will make you different when you are in interview. Two people walking in interview, one person has done the hard work, research and understanding. Other guy is like nothing. Who will get selected? Please understand. You need to work for your dreams. It's not easy, my friend. Chalo, very good. Thanks for confirming. Looks like few of the members are at least doing it, and that makes me happy. Okay, so that is pretty good. Let's move to the next concept. Good. Thanks for confirmation, guys. Let's move to the next concept. So the next concept, please write down the name, advisor. Okay, guys, advisor. while working with these Spring AI, there is a concept called as advisor. Where does this come in picture? Where does this come in picture? Okay, this concept is similar to your web related knowledge. If you have learned maybe servlets, or even in the Spring framework, while working with Spring security, these kind of topics would have come. There is a concept called as filters, right? In web related world, there is concept called as filters. Similar concept is advisors. It is called as advisors in Spring AI. Okay, what exactly that mean? Let me explain it to you with a diagram. Okay, let's say this is your Spring AI application, guys. This is a Spring AI application, and on this right hand side, this is a LLM GPT. Now just see, within 1.5 hours, your mind will start collecting the words. When I say LLM, you know what we are talking about. When I say GPT, words are not confusing. What does this mean? Knowledge is power. Just 1.5 hours ago, if you don't know all these terms, confusion will be coming. But now when I say Gen AI, LLMs, GPTs, a prompt, creating an object, okay, everything becomes clear. AI application, Spring AI, everything becomes crystal clear. Power of knowledge, power of using your time 1.5 hours properly. Otherwise, you could have just wasted Sunday, right? But today you got upgraded in 1.5 hours. Many more topics are there. Stay focused. Stay focused. Jana hai abhi dur. Okay, let's continue, guys. So let's understand the second concept. Okay, what is going to happen? We are saying, okay, we will be using ChatClient to make a API call. Fine, you will use ChatClient, and using this, you are going to call an API. Let's say end user is calling. You will use ChatClient in your Spring AI application, and you will go to this guy, and now it is going to return back. The concept of advisor is, and then you will take it and you will get the response also, right? Now, the concept of advisor says, while this request is going to LLM, or when the response is coming from LLM, if you want to do some processing, that kind of layer is called as layer of advisor. It simply works like your Spring filters itself, concept of filters. This is advisor 1, this is advisor 2, this is advisor 3. Nothing but chain of advisors are going to be there. What does this mean? Now, predefined advisors are there, custom advisors are also there. You can set up whatever you want. So what will happen? Whenever a new request comes inside, first the request is going to go to the first advisor. It will run some logic. So before you want to call LLM, you can run some logic. Like you can develop a standard thing. Okay, whenever any end user is trying to call LLM, run this basic logic, maybe a logging logic or any kind of additional logic. Okay, let's say formatting was there, right? Structured output use case was there. Whenever any raw input is coming, there will be an advisor which will put some formatting to it. And whenever response is happening, again, structured output advisor is going to do the processing also. So similar kind of scenario, but it is much more flexible. Observe, whenever a request comes, first you can run some logic, and then you will call next advisor. Now that advisor is going to run some logic. Then you will call next advisor. It's a chain of advisor. The way in your web application chain of filters are there, your chain of advisors are there. Then it will call next. So you can add a number of logics before end user request goes to LLM. N number of logics can be implemented, and then it is going to come here, and then you will be actually making the LLM call. Similar stuff happens when the LLM responds back. This response is going to be received here, and then it will be running any logic after this. Then it is going to return here. So this is how is the flow of execution in your web world. Also, it is the concept of filters. In AI world, it is advisors in Spring AI. So whether you are aware of filter or not, the concept is basically same. that when the request is going to and fro, in between you can put some business logics, write new Java classes and write some methods, and you're running some code, then you can call the next one, then you can call the next one, and in response it will go in this journey itself. This concept is concept of advisors. So between request and response, you can intercept it and write your business logic in the form of advisors. Okay, so advisors, while request and response is going to and fro to LLM, okay, you can intercept it. You can intercept it and write your business logic. Whatever you want to do. And these concept of advisors allow you to do that in the Spring AI system. So we can simply go here and click on this chat API. There is this advisors related section where they are explaining. The Spring AI Advisor API provides a flexible and a powerful way to intercept, modify, enhance your AI-driven interactions. So you can write any these kind of logics there. Okay, and yeah, you can make it more sophisticated. So usage, they are just talking about how to use it practically. They are giving some examples. Let's say while your chat client is there, while your chat client is being created, you can set up some advisors. These are your Java classes. So again, like we said, in the Spring documentation, they gave multiple scenarios and examples how to use all these concepts, how they are all arranged. So everything is clearly defined. And this is what chain they are saying. If first the request goes, it doesn't go directly to the chat model. First, it is going to go through advisors, and then it will go to chat model. Response will come, advisor will process, and then it will go back to the journey also. So this kind of loop is working with advisors. You can have more than one advisors. The way they have shown it in the first example, you can have this advisor, or you can have question answer advisor, n number of advisors. You can create your own advisors also for writing your business logic. They explain that in the bottom of this page also. Okay, how this API is, if you want to implement a advisor, how you need to write the code. If you know, next filter method we call for filters. Here we simply do like this: call advisor chain. Those guys who are aware of filters concept in web, there is called as filter chain. Filter change of next filter. I'm talking to the web guys who are aware of filter concept. But if you're not aware, this is how you do it in advisors. Call advisor chain dot next call. And there is before logic, call the next advisor, after logic. Same thing is like filter only. So because of this piece of code, they gave some example how to use this also. So when you do this call, next call, it will take it, run some logic, make a next call, next call, next call. If all the filters are over, then it will go to LLM. LLM will respond, and the return journey will continue. And you can check it out here with this example that your response will come back here, and then you can still write logic and then return it, which goes back in the chain also. So this is the concept of advisor. Okay, we need to be aware. Here you can find more about advisor. Okay, there is one more topic before we really start with our next analysis. I would just like to show you one more aspect. Okay, when we are reading through this documentation, it is continuously calling something like stream also. Stream. So even if you go to this model, look at this diagram. There is something called as just a model. There is something called as streaming model. If you check this implementation, one side they are implementing chat model, another side they are implementing streaming chat model. So what is this concept of stream? Okay, basically it is something like this. If you are aware of, streaming is like piece by piece give me the response. For example, if I ask this LLM a question, how are you, it is responding Okay, let's take an example. Let's take a normal scenario. We ask LLM, how are you? Okay. Now LLM is going to do some processing and it is going to give us a response. Now just imagine if LLM returns the full response as one shot to us, that full response is something like this one. If entire response comes back to our application in one shot, that is a standard way of communication. It is synchronous communication. You get a one shot response. Okay, you get one shot response. That is a sync communication. Another model is streaming communication. So how the response happens, this one is a synchronous communication and another one is streaming communication. Okay, what is that? Let's try to understand even that part. It will give us data pieces by pieces. So that is a streaming communication. What does this mean? Okay, LLM is going to send us data piece by piece. For example, initially this much of data will come. I am great. Initially, this much of data is coming to us. After that, it is going to say, okay, thanks for asking. This is nothing but data is coming to us in the form of stream, piece by piece. After that, it might say some next set of words. How much it will send, it completely depends. It might just say, how about? That is the next stream. Next, it sends, okay, you and how was your Sunday? So this kind of a communication is nothing but streaming kind of communication. So like this, the answer is going to come to us. So sometimes the project needs that we don't wait for full response for LLM in one shot, but incrementally we want to show. Okay? So we can say to LLM, write 100 words describing Sunday. Just see, it is writing word by word. So it is implemented in a streaming style. Piece by piece, the information is coming to me. If it is done synchronously, it will first prepare full of that, and then in one shot, we will get everything. So if you are building a Spring AI application, you have to make a decision whether you want the response in one shot or whether you want to work in as a stream. Means incrementally, whatever this guy responds back, accordingly you need to process. Again, based upon your use case, you need to decide that. But yes, the models are supporting streaming related capability also, and using ChatClient, you can get that. So please be aware of this part also. Nothing but the topic we can say sync call. Write it down in your notepad, guys. Sync call versus streaming capability versus streaming response. Streaming response from LLM. So please be aware of that. Incrementally, it is going to come. Here, sync is going to be one-shot response. And here, streaming is going to be incremental response. Okay, very good. Nice. Guys, are you done with it? Have you written it? Give a quick thumbs up. Then we will continue with the next topic. So all these concepts we need to be aware. Okay. ChatClient, prompts, structured output, converters, advisors. Because in our programming, all this is going to be used when we work with AI applications. Okay. Without knowing all this, how can we really build any AI system? So it is required that people upgrade. And these things need time and efforts. Okay, that is where big companies like TCS, Accenture, they are saying employees should upgrade themselves because it is very complex for some of the people. It cannot be taught. It needs to be self-learned. Only the people who are passionate to learn this, they will get the concepts. Otherwise, it's because everything is new. Things are changing. So passion should be there. So that is where passionate professionals will grow in future. But AI upgrading is almost mandatory. It's not negotiable. Okay, it's not optional. Chalo, thank you for confirmations. We are done with this. Let's move to the next topic. Okay. Now this is where it starts going to the next level. Currently, what we discussed is base understanding. Now comes the next level understanding. So keep your mind very alert. Lot of interesting things will be happening in the next time, a few, let's say 30 minutes, 1 hour. Okay. Currently, this knowledge, whatever we discuss right now, is stage one. Okay. This is stage one knowledge. Nothing but the technical terminology here is working with bare LLM, okay, or base LLM, or working with, okay, some people say core LLM also, or some people say vanilla LLM. This, whatever we discussed so far, this concept is working with bare LLM or core LLM or base LLM or vanilla LLM. Okay, what does this mean? Means LLM takes a request and processes it and gives response. That is what it is. It's not doing anything other than this. But the modern application needs more things from an LLM. So the current model that we have discussed, guys, everybody focus. Abhi next level pe we are going. Once these basics are clear, now comes next level enhancements. The whatever we discussed so far, it is simple stuff. There is a LLM, an artificial intelligence. You take some data like prompt, user prompt, you call it, it processes, gives you back. Now, there are some serious limitations with this LLM. It is intelligent, it can respond, but there are some major problems. So this kind of an LLM, which is just basic raw in nature, we call it as what? Vanilla LLM or base LLM or base LLM. Okay. Now, we need to enhance the capability of this LLM. That is the next topic. We will understand what are the problems, what is required. But the next thing is we need to enhance the capability of this LLM, which is nothing but also called as the augmented LLM. Means we need to upgrade the LLM, make it more powerful, not what it is right now. But what exactly is this augmentation? Before really understanding augmentation, let's understand what are the problems with this LLM. Okay, there are three major problems. Understand this, guys. Okay, problems with, let's say, vanilla LLM, the basic version LLM. What are the major problems with it? Problem number one, it is trained on data to a certain date. If you remember in the beginning days, when all these LLMs came in the market, what people used to say, okay, tell me what is today's date or tell me latest news which is happening this week. Model used to respond back, I know things up to, let's say, February 2025. So basically how these models are prepared, okay, let's say, let's flashback on that. Let's say if this is a model, how this model is prepared, how this intelligence is prepared. They take all the data, public data from the internet, all the public data available in the internet, they take that, and that is huge. Blogs, web crawling, blogs, and then video processings and images, and they take tons and tons of data which is available on internet. And let's say to certain date, for example, let's say 1st September 2025. All the information till 1st September 2025, they'll take it. Then they process it. And then they train this model. So, and then when you ask a question to the model can respond back. But it can respond back with the information which it is trained on, which is nothing but till this time itself, 1st September 2025. So if you ask anything which is, let's say, happening in October 2025, the model does not know it. And in the earlier days, the model used to simply say, "Arey, I don't know anything after 1st of September. What you are asking me?" So that is one limitation, which is still there in the current time also. The models are trained up to data of certain time. If you ask any details out after this time, model by default is not having that information. So that is the first thing which we need to understand. Trained to a certain date. For example, let's say 1st September 2025. Okay. Now, if you ask a question, if you ask any question which is from October 2025, model will say, "I don't know." And that is a very big limitation, which already solved by the world long time ago itself, ChatGPT and anything. If you ask some question to ChatGPT now, it is going to tell what is today's date also, what is happening this week also. Because what did they do? They augmented the LLM. They made the LLM better, bigger, with more capability. It's not a vanilla flavor of LLM that we are using. We are going ahead with the augmented, a more capable system is running behind the screen. Okay, but this is one big problem. New data, information is not there. Okay, the second problem with this kind of vanilla LLMs or base LLMs is it can only tell you text, but it cannot perform actions. That is the second problem. When you ask something to, let's say, ChatGPT also, so you put some words in, it will respond back with whatever text. Let's say this is a chatbot of a company, support request person. You're talking to the chatbot. So chatbot is responding back to you, that is fine. But behind the screen, if this chatbot is not able to solve your problem, if this chatbot collects all your queries and then it inserts a record into the database saying so and so user is having so and so concern, writes it into the database so that some support agent will read it from the database and manually then try to solve it. Some support person, human being, will read the value from the database and then it will understand query that, okay, AI was not able to solve it, let me solve it. Means we want LLMs to do more now. I think recently this came in, I think Swiggy or some provider, they have started giving MCPs. Means now you can chat and on behalf of you, now food and everything is going to be selected also. So what is happening? You want LLMs to do more, not just tell you text, not just give you the instructions, okay, step one, do this, do this, do this. No, you want LLM, okay, if you know what needs to be done, why don't you do it? Let's say, for example, dropping an email. So LLM can write a great email. We will say, you know which email you want to do. I can simply say, okay, send email to, let's say, abc@gmail.com, and we will give the context, what to be prepared in email. So what LLM is going to do? First, it will prepare the email, and LLM should send the email also. Means expectation of the market and the project requirements is changing from LLM. It's not just about querying and getting answers. It's like LLM should take actions. That is the drawback with vanilla flavor or base flavor. It just tells, it cannot perform actions. And with augmented LLM, it can do it. So with augmented LLM, you will get contact to latest information. Second, with augmented LLM, you can make LLM take actions. Means LLM ka bhi next level is happening already. It's already happening. It's already done also. Many companies already done also. But now we are understanding, because slowly it will start into our Indian IT sector, into our Java development. So we have to learn all these concepts and then start building the applications accordingly. That is where we are doing these discussions. Okay, fine, let's continue. So that is the second problem. LLM cannot take actions. So with augmented LLM means make more capability for LLM so they can take certain actions. And here we took some example. Okay, we want LLM to send email, okay, to create a customer support request, so not just tell us text, but want to take actions. So how to make that? Okay, that is required. And the third very basic problem with LLM is it is stateless. Stateless means, okay, you make two API call to this LLM. Okay, this is a yellow box. This is an LLM system now. You make first API call and you say, we are doing a Spring AI session. Okay, Spring AI session on 26th October, 10 a.m. we started. Okay, so let's say Tosif and team is doing Spring AI session on 26th October. And let's say LLM is going to respond, Arey, wow, very good, this is good to learn, good to do everything. Okay. Now, you write a next user prompt and ask LLM a question. This is the second problem with vanilla LLMs. You ask a question, okay, which topic is being discussed by Tausif and team on 26th October? LLM will be blank. It does not know what happened in the previous request. You ask LLM, who are doing this topic? LLM is clueless, does not know. You ask LLM, Tausif and team is doing Spring AI session on which day and time? LLM is clueless. That is what is stateless. It does not maintain the state. That is the default behavior of the core vanilla LLM. It does not remember what you're trying to tell it. These are significant problems. And if you want to use LLMs for application development, some solutions are required for this. Otherwise, problems will be coming. Okay. So it does not remember. That's crazy. So that's the third thing, stateless. Every call to LLM is considered as separate. It does not remember, okay, the previous things, previous state. And with augmentation, you can even remember. That's the power. You made a better LLM, more powerful LLM with augmentation capability. Remember the state also. Okay, so that is what is the power of problems with this, solutions with this one. Okay, guys, are we clear with this? Can you write it down in your notepad? What are the three major problems? You can have this conversation with a lot of people, with your friends during interviews or wherever, right? It's a pretty good thing. Can you write it down? What are the main three problems with the vanilla LLM? Main three problems with vanilla LLM. It is trained till a certain data. After that, gone. It cannot take actions, only tells you the text. Third, it doesn't remember. Once you're done, give a quick thumbs up. Three major problems. Once you're done, please give a quick thumbs up. Chalo, we are done, like 2 hours session done for 2 hours. We have more, roughly around 1 hour or maybe some more time. Let's see, I will try to cap it up at 1, but let's see, maybe 15 more minutes here and there might be required. Okay, some of the guys are done. Very good. Very good, guys. Be involved, think, take notes, study, analyze, research, grow your knowledge, and that will create a very positive impression during interview time. Okay, let's continue. So these are the three major problems with augmenting the LLM. Augmenting means enhancing the capability. Okay, enhancing the capability of LLM, we are able to solve these problems. Okay, and these guys, Anthropic has given some nice blog about all these concepts. Okay, let me just launch that one so we can have a quick look about it. Anthropic, who is the creator of Claude, they have spent some nice short blog about agents. We will discuss something about agents as we continue with today's topic. But just observe here. This is what they say is a augmented LLM. Means your core vanilla LLM, but with the capability of retrieval, tools, and memory. Okay. So how basically you solve these three problems, what we discussed, is by this diagram. You enhance the capability of LLM, that is called as augmented LLM. Okay, I will paste this link also in our chat. Let's have a look here. But this concept of augmented LLM is simply saying, along with your LLM, now you enhance the capability with some retrieval feature, tools feature, memory feature. Let's take a screenshot of this diagram and we can put it into our diagram notes also. I will give you all of these diagrams by the end of today's session. In our WhatsApp group, we will share it. Okay, but just be aware, this is what is augmented LLM. LLM with enhanced capability now. Augmented LLM. It can do more things. It can do all those things. It can, that is where memory, it can maintain state using memory. It can take actions using tools, and it can gain information using retrieval process. Okay. So if you really boil it down here, LLM, it can get latest information. How? By using retrieval process. By using retrieval process, it can gain access to the information. It can take actions using tools concept. And it can remember the state using memory concept. Okay. So abhi the power of this, we have to discuss one by one. Okay. What is retrieval concept? So there are multiple things here. We will discuss the primary use cases about retrieval. Let's start getting to this point one by one. Guys, everybody stay focused. We will start discussing new and new topics now. What is the retrieval process? Okay, one of the popular use case of retrieval is RAG. Okay, and they have defined it as part of this section also. Retrieval augmented generation. So retrieval augmented generation, that is the concept of RAG. Okay, what basically it says, let's try to draw it with a diagram here. Let's say a request is going, so this is the LLM. We will understand first basic scenario of what is RAG. Okay, let's say you have some information in your system. Some information, maybe you have information in a DB or wherever. Okay, you have some information with you. Whenever a request comes to your application, let's say this is your Spring AI application. This is your Spring AI application. So whenever a request comes, step number one is you go to this kind of a data source. It could be documents, it could be database, it could be whatever. But whenever a request comes, you go to this kind of a data source. You collect the data, and when you are sending the prompt to LLM, you pass this additional data. So LLM does not know this kind of information, but retrieval, RAG basically says retrieval augmented generation. Nothing but first you retrieve the data. Augment means along with your query which you are sending. So let's say your prompt is there. Along with that, you will put this additional data also. So step number one is you retrieve the data, retrieve, then you add that augment. So that is retrieval augment, and then when you make a call to LLM, this guy is going to generate. So that is where the term comes, like RAG, Retrieval Augmented Generation. The basic problem is LLM does not have this information, but to answer a user query, it needs that information. How to do that? Approach is using RAG, Retrieval Augmented Generation. It is that simple. A request comes to your application. LLM does not know this data, so it cannot respond back, or it will give incorrect results or hallucinated results, or tell I don't know. But it will just give some crap which the user does not want. We know that for this query, this data is more relevant. What we can do? We can implement a RAG, Retrieval Augmented Generation. 3 steps. Step number 1, you retrieve. Step number 2, you combine it with the request, augment it, combine it, enhance it. Step number 3, send it to LLM, and then LLM will generate a response and return back. Now, valid, meaningful response will come back. Okay, so that is the concept of RAG. You keep your data with you in some data store. Okay, in some data store. When a request comes, you fetch the relevant data from your data store and then augment, nothing but combine, add, enhance, combine with incoming prompt and send to LLM. Next, LLM will generate the response based on what you have sent in prompt, additional data in the prompt. So this is what is a simple RAG process, Retrieval Augmented Generation. Okay, let's try to understand this with the documentation of Spring also. Let's read it, guys. The technique term RAG has emerged into this field to address the challenge of incorporating relevant data into the prompt to get accurate AI responses. Okay, first part at least we are clear. Now we need to understand the second part. Before reading through this second portion, let me give you another clarity, then you will understand the second section. Okay, what is that another clarity? Focus here. Let's assume you have 100 files, and these files are having, let's say some files are having 500 pages, some are having 100 pages, some are having 1000 pages, some are having maybe 2000 pages. And this is the data which is there with you. Understand the problem statement first, guys. Everybody please focus. Now this is very important discussion. Everybody please focus. Whenever the input query is coming, you have lot of information with you. How do you give and what do you give to LLM? First concept of RAG is very simple, that when a request comes in, get the data, give it. But now there are bigger questions here. What kind of data? What kind of data? And how much data we should give? Should you give like 500 files with all these pages? It will be too much information. We cannot, there is a topic called as context window right now. Let's not discuss into that. But just imagine there is a limit of how much input data LLM can process. For now, just know that. You cannot load infinite amount of data, LLM will not respond back to you. That is the reason in these conversations also, if you put very big amount of data, LLMs will say, okay, out of memory, not able to process. So please, we need to be aware, there is a concept called as context window. So LLM has limit how much data it can process in every request. You cannot give more than that, otherwise it will fail. Now let's understand the problem statement. What's our problem statement? We have a lot of information with us. And when a user query is coming, we need to give the correct information from these pages to LLM. How do we achieve that? That means you need to write a different business logic here, that given an input query, search for relevant pages, paragraphs from this book, all these books, PDFs, combine those and then give it to this guy. Means additional logic needs to be written. You cannot blindly take everything and send it. That is the problem. So RAG says approach is very clear. Okay, before sending the data to LLM, you need to retrieve and then send it. But the problem here is we have a lot of data, what to retrieve, and how to find, given the input query, which is that relevant information. That is a big problem which needs a solution, and the world has already solved it. And one of the common practice for this solution is implementing RAG using VectorDB. The way you have SQL database, NoSQL database. Now, vector database is a very common database which is used in AI programming. Vector database. Okay. Vector database का basic concept is it knows the meaning of data. Vector database knows the meaning of data. Okay, let's try to understand this part. Vector database, it knows the meaning of data. It can compare two data and say whether it's related or not. This is the power of vector database. So vector database, it knows the meaning of data. So when we are saying write 100 words describing Sunday, vector database knows what we are actually asking. Okay. When we say, how are you doing? Vector database knows what we are asking. Now just imagine, look back into this diagram. We have 100 files with lot of data. What we will do is, we will take this kind of a data and store that into a vector database. Store it into a vector database. Maybe as many paragraphs, many paras, we will break down these all files, pages and everything into paragraphs. Vector database knows the meaning of all of these paragraphs. Okay, what do they really mean? And now just imagine, when an input query comes to the system, we will go, as per RAG implementation, we will go to this vector database and we will say, hey, input query is like this. For example, how are you doing? Or tell me something about the latest news which is happening in your company. Let's say in this company, they have a news publication which is not public. So LLM does not know it. And all of this internal company news is here. And now user asks a question, tell me latest tech update of your company. So let's say this is a user query. LLM does not have this information. This is internally within the company, maybe in the form of PDFs or blogs or whatever. What we will do is, we will take all of that data, break it down into small paragraphs and save it into the vector database. Next, whenever a question comes, tell me latest information about your company, the system is going to go to the database and meaning-based search is going to happen. And that is called as similarity search. That's the terminology. Similarity search is going to happen. Means for this input query, whatever are the relevant paragraphs, give me only that. That is the concept, guys. So whenever a user has asked a question using vector database, we will do similarity search. Okay, hey, for this input query, what is the relevant data with you? Give me only that data. And then that becomes part of the retrieval process. RAG ka R portion, retrieval. but meaningful data, relevant data only we will be getting. And then we will do augmentation, which is nothing but take that data, combine it with the prompt, and then we will send it to LLM, and then generation is going to happen. And that concept is the concept of RAG. Take a minute to digest. All the information that we have, we will process it into small paragraphs or chunks of data, small pieces, and then load it into vector database. Vector database knows the meaning of the data. It can compare two data and say whether they are related or not. Whenever, that's the default nature of VectorDB. That's where VectorDB is utilized in AI-based applications a lot because of these advantages. Second thing is, whenever a user query is coming, we can go to this vector database, find only the relevant paragraphs where the information is available, and then take it and then augment it with the user query and then send it to LLM. And we will tell LLM, hey, user has asked this query and this is additional data that we have. Please respond. So then it will do generation because it is a Gen AI. It will generate new information by processing this, and then it gives you the response. That flow is RAG process. Retrieval, augmented generation. Are we clear with this, guys? Are we clear with this? Please give a quick thumbs up. We launched new terms here. Vector database. It has meaning, okay? And all your data needs to be first saved into the vector database. Next, when the user is running your query, it gets it from the DB, augments it, goes further. Are we getting it, guys? Give a quick thumbs up. Are we clear with this? That concept is RAG, Retrieval Augmented Generation. Very good. Very good. Concept of RAG. So first, plain LLM. It takes a request, gives the response. Now you want to enhance. Plain LLM ka knowledge has a cutoff date. You want to enhance the knowledge. How can LLM do that? Okay, approach number 2. You take the data, give it to that guy. Now that guy is smart. If it has the data, it will do it for you. Okay, very good. I think now with this explanation, you can understand what Spring documentation is telling you. So let's read that Spring documentation, guys. Okay, as everybody with focus, please read it along with me. Let's read. First line, though we understood. We need to incorporate relevant data into the prompt for accurate AI responses. This part is clear. Now let's understand the second portion. Okay, the approach involves a batch processing style of model where the job reads unstructured data from the document, transforms it, and writes it to a vector database. Nothing but this portion. You have a lot of unstructured data. You need to write batch processing, means some other tasks will be there. If you know Spring schedule or cron jobs, nothing but some background process. It will take all of this unstructured data, transform means put it into some maybe paragraphs and pieces of chunks, and then store it into the vector database. That is what this line says. So guys, the approach involves batch processing style where the job reads the unstructured data from the document, transforms it, and writes it into the vector database. Okay, it is basically called as ETL process, extract, transform, load. So there is a terminology in IT, ETL, extract, transform, load. So that is what this is. Extract the data from these files, transform, convert it into paragraphs or chunks, and load, put it into vector database. So it is called as a ETL process also. ETL, extract, transform, load. Okay, fine. Next, moving on. This process is a background process which runs, keeps the data here. Next, moving on. What happens? The vector database is used in retrieval part of RAG technique. That is what we said. When the retrieval happens, you will get it from there. Next, as part of loading the unstructured data into VectorDB, One of the most important transformation is splitting the original document into smaller pieces. Nothing but how do you split it into smaller pieces? Okay, the procedure for splitting the original document into smaller pieces, some kind of guidance is given. Okay, how exactly you will take this data and break it into smaller pieces. So fine, they gave some kind of a process for that. Fine, whatever that process is. Okay, next, the next phase in RAG is processing the user input. So when the user is asking for an input, so when the user question is to be answered by the AI model, read this part very clearly along with me, guys. The next phase, the first part is load the data into VectorDB. That process is ETL process. Technical term is ETL process for that. Next, the next phase, processing user input. When a user question is to be answered by the AI model, the question and all similar document pieces are placed in the prompt and is sent to the AI model. This is what we already discussed here. When the user request comes, similarity search will happen, and that is what they are saying. The question with all similar document pieces, like pieces, right? It's in chunk, it's in paragraph. So they are placed in the prompt and then sent to the AI model. And this is the reason we use vector database, because it helps to find similarity. And that's what they are saying. It's very good at finding similar content. So whatever we discussed, after that, understanding this paragraph is a piece of cake. That is what it is. Now, they have given very nice diagrams to clearly explain this portion. I think you should understand this diagram 100% also. What is that? Let's spend a minute here. Offline process means background process. Take the data from source. So using a reader, you will read the data and you will have all the documents with you. You will use transformer where splitting logic will be there. How to split this document into smaller portions, chunks, and then writer is going to write it into vector database. This process is the ETL process: extract, transform, load. That's it, a diagram which is specifying it. Once the data is available in VectorDB, part 1 is completed. Now runtime, when the user is asking a query, what are you supposed to do? You will put a retrieval. RAG is about retrieve. So you will put a retrieval request to vector database. It will pick the queries, the chunks. You might have a lot of data, but only 3 chunks are important for this example. So whatever relevant information, similarity search, relevant information is there, it will be retrieved. And then augmentation, the user query and the retrieved information is combined together. That is augmentation portion. And then that becomes your full prompt. Observe this prompt. The full prompt will become user query and all the information retrieved. Okay, so this is full information which is retrieved, also called as context information. Okay, and then we go to generate. Nothing but using chat model or chat client, you will be making a call and then final chat response is going to come back to you. Okay, so this process is the RAG process. We can take this diagram also so that we can have everything in one place in our notes section. Okay, so this flow is defined by Spring, guys. Please be aware of it. Okay, chalo, ye to ho gaya RAG. Now, point is, we discussed there are 3 basic areas. First one is retrieval part. How do you augment an LLM? Retrieval part. Retrieval, primary use case of the current time is RAG working with vector database. But vector database means you need to take the data, load the data. There is another form of retrieval. Let's go to that topic. There is second commonly used practice of retrieval. Second practice of retrieval, which is what? Doing web search. That is a second practice of doing retrieval, web search. So now in the market, there are some providers which are giving APIs which will help you to do web search. Web search is like you go to Google and then you type something and then multiple blogs and multiple information will come. So in the real world, there are some providers which are giving APIs, and using those APIs, you can simply do web search. That is another form of RAG implementation itself. Okay, what does this mean? Let's go back to the diagram. Let's imagine you have your Spring AI application. Okay, that is also part of the RAG flow, but it is done differently. This is also RAG flow, retrieval. So RAG with VectorDB is one use case. RAG with web search is another use case. What is that use case? Okay, in the real world, please be aware of all these terminologies. In the real world, when an invoker is asking a query, let's say you don't have your information in VectorDB, but you might need information from the web, nothing but globe. This is internet, web. So what you will do, you will just make a API call to this web APIs, which is going to give you web information. And then you will specify, hey, this is my question and I want a response. So whatever is the relevant response, maybe the top 5 information, that part becomes a retrieval part again. That is a retrieval part again. So instead of going to the VectorDB, you will make a web API call where all the information of web is available. The relevant information will come back to you. Then you will do the same thing again. Your user query, you will combine it with the data which you got from this web request. So this portion is again augmentation itself. So that is the second common use case that we can see, augmentation. And once it is there, your prompt is going to be created, and this prompt you can pass it to LLM. That is a second common use case how RAG can be seen in the project related world. And then you basically make a call to LLM using your chat client, and accordingly LLM is going to process. Still, it's doing the basic thing, but we are enhancing the capability. We are doing the hard work at our side and telling it to LLM ke bhai abhi to bata. And then LLM is going to do the generation. So again, this is a RAG flow itself. So please be aware of that. And then this becomes these are the common 2 use cases. There are several other ways by which we can retrieve more data also. But for now, to get the basic understanding of RAG, just be aware. So RAG is not just working with vector databases. Please be aware of that. That is one of the use case. There could be another scenario where you can work with a web-based sources. Okay, that could be second case. Basically, retrieve, augment, generate. That is RAG. Okay. Team, are we clear with this? Are we clear with this? Please give a quick thumbs up. Just write down RAG. I think in your notepad, you should write 2 things here, guys. One, you write it RAG with VectorDB, and into bracket, you say meaning of the data. Write down this RAG with VectorDB into bracket meaning of the data, and RAG with web search into bracket searching latest information from web. Okay, write down second, RAG with web search searching latest information from web. And you would realize all these models now, right? ChatGPT is a AI application. We are trying to talk about building a kind of AI application like ChatGPT, right? So ChatGPT already has all this. It has VectorDB, it has web search based access, and it has all this latest information. And they are some of the primary leaders of the world, the Claude, the ChatGPTs, and all these other Google Gemini and DeepSeeks. So they are enhancing, and then patterns are coming out which other projects, and then standards and design patterns will be formed. how to work with these kind of AI based systems, and then the rest of the world will start upgrading and making it, right? All the companies are saying we want to become AI first, means we need to use all these patterns and start building our systems also, right? It is good. Chalo, let's move to the next one. So we can say, good, we can say this part is clear. To some extent, we got retrieval part. To some extent, we got retrieval part. Now, what am I going to do here? Let's look at this documentation. RAG we understood from this central portion. ETL pipeline also we understood from the central portion. But in this part, in the main documentation, they have explained how to implement RAG using Spring. Nothing but working with vector database. So again, how to work with that vector database, it is there. Further, if you see which type of vector databases, we know SQL DBs, right? MySQL, Oracle, PostgreSQL, SQL Server, like that. What are the vector databases available? Just see, these are list of vector databases in the market. Azure AI, Azure ComboDB, okay, Chrome, Couchbase, Elasticsearch. They are providing support for vector database also. Okay, Milvus, MongoDB, Atlas, Neo4j, OpenSearch, Oracle. So these guys have started providing Pinecone, Qdrant, okay, Redis. So these guys have started providing some support for vector DB also. So what do you need to understand? When I click on this vector DB, so refer to this part to check what kind of vector DB support is available by Spring AI. Further, how to do the coding for the RAG? They have specified it here. So with examples. So again, they are using some advisors. We know that every time a request goes, advisors come in picture. So some predefined advisors are there. Just have a look here. Try to understand this code. They created some question answer advisor, which they are putting it. Okay, whenever a request goes, question answer advisor should go. In that, they are putting a vector store. Means whatever we discussed, okay, go and fetch the data from the DB. Now Spring AI has made it so simple for us. We don't even have to write queries for that. A Spring Bean will come of vector database. You just put an advisor. They already wrote the relevant code. It will simply go to the DB, collect the data, add it to the prompt, send it also. Implementation is so simple. That is where I'm asking you, please read this documentation. Conceptually, it's very good. Implementation, Spring has done further hard work. So you don't have to do it. Just use these proper advisors, connect to the right data store, and it will get it, append it, send it, get the response also. Easy to work with. So Spring is doing a lot of hard work behind the screen for us. Okay, fine. And now they are giving, you can customize the vector store also. Like how do you want similarity search, right? How do you want this kind of similarity? So some parameters are there. Please read about it. Threshold 8.8, what all this thing means. Spend some time, read about it, and you will get the confidence. But yes, they speak about this process of RAG, how this happens with technical code, how your prompts will be sent internally to LLMs. They have given some examples of all of that also. Next, what is the ETL pipeline? They explain that also. Okay, which classes will be used for reading, transforming, and loading. Okay, they mentioned okay, what kind of classes they created. Okay, supplier list. So just observe these class names. PDF document reader, token text splitter, document writer, document transformer. Means some predefined classes and interfaces are there. You can use this for basically reading it, splitting it, and doing the other stuff. They gave nice examples about how they have arranged all these internal classes. So yes, every topic may now we have to dig more and build one application so that you will get practical hands-on. Maybe in future sometime we will do practical POCs about all these sessions also. But today is a master class where we touch it across the entire area. Okay? Fine. So that is what this is. ETL pipeline. So I think we can just copy this RAG related URL and we can copy ETL pipeline URL also. Super. This is done. So we can say now we have some fair bit of idea about retrieval. Okay, LLM does not know. We will take it and we will give it. Okay, guys. Now let us take up as a poll. Let us take as a poll here. Can you explain in any discussion? Okay, are you clear with what is GenAI? What is LLM? What is Vanila LLM? What are limitations? What is RAG? What is VectorDB? Yes or still 50-50? Chalo, let's see where we are. Now, when anybody asks you for any discussion, what will be your answer? Can you just put it now? Let's see. In the beginning of today's session, when we started saying how much grip we have on this topic, the poll response was something like this. Majority were into, 96% were into, okay, oh, we are new to all this. Now, we already covered GenAI, we already covered LLM, VectorDB, RAG. Now, let's see how much our confidence is. We are seeing around 67, 68, roughly 70. 20 member only voted. Arey, baki log bhi aa jao. But you can see now equations are changed. Within 2 hours, 3 hours, we are getting the right knowledge. So it's possible to learn, but hard work is required. But becoming ready towards a new future is very easy and practical. So already we can see here at the end point right now, this much of understanding, 71% is having now good understanding. So we change the equation if you see. Okay, so we change the equation right now. Let's paste this and let's see how it goes further till the end of today's session. Okay, now there will be certain factor. The people who are not available, earlier 80 people were there who voted, now 24. Point is, if you are there in the call, you should vote. That means you are focused, you are alert. If you're not there in the call, there could be a lot of reasons, right? Due to network, some people might not be able to continue mobile data for 3 hours. Some people might feel this topic is very much complex and then struggle. But the point is, regardless of reasons, we have to learn it, we have to master it, we have to showcase it, and this will make us future ready. Otherwise, you will be stuck with traditional programming and the world around you will change and you will become outdated, and very soon drastic changes will come, and then you can just sit and cry, okay, what happened to my life, why am I not getting calls? But you need to be ready for the future, so upgrade yourself. Use this today's session to open your thinking towards AI and start doing all these things practically. That is the reason we are referring this documentation, so you get comfortable with whatever is mentioned. Everything we are trying to cover of Spring AI with quite good amount of details. Okay, fine. Chalo, moving forward. 27 members have voted, 70-30 equation have changed. Confidence of the people is growing already. Okay, let's move forward. Let's go to the next topic. Retrieval is done. Now we will be picking tools topic. Okay, tool is another way to upgrade LLM's capability. Let's understand what this tools concept means. Guys, देखो, tools concept basically does two things. In the previous time when we discussed tool, we said only one thing, okay, LLM can take action. Guys, everyone, please be focused. This is one of the use case of tool. LLM can take action. Second use case is tools can be used for retrieval also. Okay, nothing but we do retrieval via, let's say, RAG or other places. Now, tools can be used from two perspectives. One is for taking actions, another perspective is for retrieval. Okay, what exactly this means? Thoda sa let's try to understand. Guys, everyone, please focus. This is tricky topic and very interesting topic. Maza aega. If you get this part now, it will be really fun. So guys, everyone, request you to focus. We are discussing the topic of tool. What exactly this is? We have our Spring AI application. We have Spring AI application. And we have now LLM. Okay. Now, what is going to happen? What is the meaning of tool? Let's say in your project, you will write some business logic. You will write some business logic. You will write some business logic. This business logic could be anything. Send email. Insert row to DB. Insert row in DB. Or it could be any business logic, right? The way we have been doing traditional programming, building features, any kind of business logic you can write. Send email method, insert into DB method for any kind of actions. Let's say you have written this. Now we call this business logic, which we are writing as tools. So this is nothing but tools. Okay. Second funda here is whenever the input request is coming, let's say there is an end user and the end user is giving input request to our system. This is very interesting. What we will do is, so we are having now prompt. Prompt is going to have the input user query, user message. What additionally we will do is, in the prompt, we will include details about send email. Okay, what does this method do? We will have details about insert values in DB. What does this method do? So some details will be there, not just the names. Details will be there. What this method does, what this method does. And now we again update the prompt in this manner. So what we are going to do, whenever a user is asking the data, we will be taking the user message and we will be further adding the details about these tools. Tools are nothing but business logic, which we have written as developers. And you can write any business logic, right? But the details about that, okay, what logic is written in this method, what logic is written in this method, those details you will take and add it to the prompt and then give this to LLM. Next, based upon the user message, if the user message includes something like send me email, something like this message is coming, what is going to happen? LLM is going to read these kind of tool descriptions. So these two information which we have provided to LLM now understands that. And now, guys, listen this part very carefully. When a question comes, okay, send me an email, LLM is going to read, okay, is there any tool which can send an email? So LLM is intelligent, it's artificial intelligence. LLM understands that LLM should further send email, nothing but take an action. So what LLM is going to do, LLM will check, is there any tool available which can take action? And yes, LLM is going to find that yes, this tool is available for this purpose. Next, what LLM is going to do? LLM will respond back to our Spring AI application saying call send email tool. LLM will not call it directly. LLM will ask our application. Okay, LLM will ask our application to call tool send email. Next, in our application should now call this and execute this. So now that is where application is going to call this. It's a method call. Whatever logic you write here, that logic will execute. It will execute it, take the response, and then inform this response back to LLM. Lot of communication is happening between to and fro. It will call this, execute it, and inform the response back to LLM saying, okay, I executed the send, I got this message. So it will do this. Okay, Spring AI. We will explain it multiple times. Don't worry, this is first time I'm just walking through the flow. Spring AI tells the response of tool call to LLM. Okay, Spring AI is going to tell the response of tool call to LLM, and then comes LLM will further process it. Okay, LLM will further process and then give the final user message. Okay, what needs to go in response, and then that is going to be given back to the user. Okay, yes, we have sent an email to you and these are the things. This much of communication is tool calling. Take a minute to absorb what is the end-to-end strategy of tool calling. Point number one is developer is supposed to write business logic, which is called as tools. Why it is called as tools? From the perspective of LLM, they feel like these are tools which can enhance LLM's capability. So we just coined the term as tools. Methods only, functionality. But from perspective of LLM, these are additional tools. Human beings, we created a tool called as water bottle because we wanted to put water in it and we can drink. So this is a tool. We have a hammer, that is a tool. Our laptop we created, it's a tool which enhances human capability. So this send email, we call it as a tool because it enhances LLM capability, because traditional LLM, vanilla LLM cannot do all these things. So even though we are doing it, but decision to call is done by LLM. So it is given as LLM capability. Second thing you need to understand, LLM is never calling it. LLM is asking us that we should call it. So you need to understand, when you use Spring AI, so as a developer, we don't have to call, Spring AI is going to call. So that's the power of using the framework here. Okay, that's the power of using framework. So our life is simplified. We simply create a method and configure it. Communication between Spring and LLM is going to take care. Let me explain you the process one more time. Guys, everyone please focus. Everyone please focus. As a developer, we are supposed to write business logic in some methods. We will use some annotations and we will write business logic. It can be any business logic. Once we have written this kind of business logic, next, user is asking for certain query. We will take all and we will write description. This description part is very important, guys, because LLM, how will LLM understand that I am supposed to call send email? So we have to write lot of valid description, detailed description, so LLM does not make mistake. You can imagine, it's a machine, right? Artificial intelligence. What if LLM decides for send email, call insert into DB? If you write wrong description, LLM will get confused. So you have to make the descriptions very clear here. Okay, what is the meaning of send email? Let's say this send email is expecting some parameters. So like email, text body, maybe CC, to section, whom it should be. It might be a lot of parameters also. You need to describe these parameters as well, because LLM will intelligently decide, call this tool with these many number of parameters, it will give the data also to be called. So very important point in tool calling. In tool calling, okay, description of your tools is very important point. If you make mistake here, LLM can wrongly call the tools and entire business logic goes for a toss. So you are relying that LLM will make the right decision. So guys, what are the steps? Step number one. What are the steps? Step number one, developer writes business logic as tools. Developer write business logic as tools. Step number two, when user call queries, okay, then, or let's say along with tool, developer should write detailed description of tools and parameters. This is very important part. So LLM can know when to use it. Very important part. Step number three, end user sends the query. End user sends the query. Okay, Spring AI system will get this tool information, and add to prompt. Step number four, prompt goes to LLM. Step number five, LLM realizes that I should call some tool and what data to pass for all parameters. Step number six, LLM asks the AI application, nothing but your Spring AI code, Spring AI, to call the tool with the data, Step number seven, Spring AI, we don't have to do it. Spring AI will call the tool method and process and take response. Step number eight, response is sent back to LLM. Step number nine, LLM decides. That's the artificial brain which humanity has created, artificial intelligence. So LLM decides whether the work is done. If yes, then gives final answer to Spring AI. And step number 10 is Spring AI gives it to user. That much is the flow, guys. Interesting, right? You write your business logic, you tell it to LLM, okay, hey, we have these kind of methods. If you need any time, you can call us. If LLM feels okay, it's not required, it will not call. So, but you provide information, LLM will use its knowledge and then identify, oh, I need to call some tools, and LLM is going to call that. And then LLM calling that means it asks our application that you should call. So our application will call that, get the response, give it back to LLM, and then LLM will decide what to do next. Maybe 2-3 tools should be called. So maybe LLM might decide, okay, now email is done, now insert into DB also. Based upon our prompt, LLM is going to act. And maybe after inserting to DB, we will respond back. So that is where AI agents are formed, which does many things together. Sends an email, inserts into DB, does some other activities, and then finally says, my work is done. Lot of decision making LLMs are doing because of tool capability. Now it is going into AI agents where they can think, okay, there is a requirement, we will write proper prompt, based upon that agents will start acting, it will start calling tools, and we are heading into the miraculous world of AI where we will just set it up once, leave the system, AI will do all these things by itself. It will decide, it will call, it will update, and it will give a confirmation, okay, I did all of these things. It will decide on the fly. There is no static coding. You are not writing your code, okay, first do this, then do this. It's all decided by LLM. When I should do this, when I should do this. That's the power of artificial intelligence. It's powerful if you really understand कि क्या बनाया है भाई, right? So guys, are you getting it? Can you give a quick thumbs up? Are we clear with this? Team, are we clear with this? Okay, nice, good to see. We are getting a lot of confirmations. The time is up, but I still want to cover a few topics, so let's extend it. If those members who are not able to push yourself, come on guys, I know all these things, still I'm pushing myself. कि 3 घंटा हो गया, Sunday time. I could have like roamed around somewhere. Sunday ko masti marte. But I felt no, this is important. We have to share it because you have to be ready. Because 96% of the people are not aware of this, and this is the future. So it is important that everybody understands. So I'm pushing myself 3 ghanta. I mean, let's go for 1 more hour if there is like topic left. So yes, there is a topic left. I want to discuss that also. So I will push myself for 1 more hour. Let's see how many of you will go one step ahead also. In case you are not able to continue for another 1 hour, maybe watch the recording later. But game khatam nahi hua. The game is not over yet. We are just at the second step, tool capability. That's where we are doing one master session, so you don't have to further search web and get still confusion and questions in your mind. So if possible, try to continue, because I am continuing this live for next maybe some more time, maybe 30 minutes, maybe 1 hour, I don't know, but we have to discuss more topics. So I am ready to continue. If you are ready, chalo, badhte aage. Okay? Because I don't want to break this. This is important stuff, and we should finish it at one go, so your mind can visualize where we are doing, what we are doing, and this world of AI will not scare you anymore. That is the aim of this today's one session that we are doing. So let's go. Okay, I am going to do it. Okay, whether you want it or not, session to hoga bhai hoga. Chalo, let's continue, guys. Okay. So we understood something about tools. Let's read it from Spring AI documentation. The way we did with RAG, then we got full understanding. Now we will understand the concept of tool as per Spring documentation. And I think we should be able to understand it very easily because we have gone to the very depth understanding of tools. Let's see what this is. Tool calling. LLMs are frozen after training. It leads to stale knowledge, and they are unable to access or modify external data. They cannot do all these things. The tool calling mechanism overcomes this. It allows you to register your own service as tools. Nothing but these two things which we spoke about. Send, these are our own services. It allows you to register your own services as tools to connect the large language model to the APIs of external system. So from the perspective of large language model, we are external system, and with the concept of tools, we are giving the capability that LLM can connect with external systems. That is what this is, and that's what they have explained till this point. These systems can provide LLM with real-time data and perform data processing actions on their behalf. Now just imagine, you can write any kind of logic here. Now you write a method which gives real-time data. It's up to you, right? What logic you want. Write your real-time data. What is current date? What is current date? Let's say your tool is like that. So we can say, okay, it is even real-time data. LLM does not know what is today's date because its knowledge is frozen. But if we define current date kind of a tool, then somebody asks a question, can you tell me what is today's date? For example, if we ask it to ChatGPT, okay, tell me today's date. Let's see what this guy does. It is able to pinpoint. It is 26th October, Sunday. How LLM or GPT knows it? It does not know. Somebody has written some real-time tool which LLM called, and that query you can write in Java, right? Utils, date functions are there, local date times are there. Using that, you can write a query and that will give you the date. So LLM used it behind the screen, called one of the tool, got the current date and gave back. So that is what this statement is saying. It can get real-time data and perform data processing actions on your behalf. Let's say, for example, you have written a tool which is going to make a web search now. So LLM will know, okay, for getting the date, making a web search is more important. No, not required to call all these other tools. So you have created a web search tool. Guys, try to imagine the power is unlimited because you can write any logic, right? Now LLM can call whatever logic and it will all work magically. So here you are doing a web search. Here you are maybe calling another microservice for doing whatever other things. So it's all up to you. The system is open for massive potential and implementation. That's what this guy is saying here. Okay. The tool calling mechanism addresses this shortcoming. It allows you to register your own service as tools, to connect the LLM system to APIs of external system. These systems can provide LLM, means this system means the systems where tools are implemented. So these systems can provide LLM with real-time data and provide data processing actions like sending an email, or maybe inserting something into the DB, data processing actions on their behalf. Next, Spring AI greatly simplifies the code you need to write in order to work with tools. It handles, so Spring AI is doing some amazing work here behind the screen to make all this thing possible. You don't even have to worry. Simple setup at your part and Spring AI does all this to and fro communication. That is what they are trying to tell you. Okay, we have done that work. You just need to use an annotation @ tool and magic is going to happen. What is the flow? Please understand. Whenever a chat request comes, along with your chat request prompt, we even have the tool definition. Okay, what this tool is doing, we said, right? Lot of description and everything should be available. So yes, along with your request, the tool related information will be there. Spring AI is going to take this kind of a prompt and give it to AI model. Next, AI model will decide, do I need to really call any tool here? If it feels yes required, it will call back to our application. Means developer, we don't have to do now anything. We have used @tool annotation and it is going to be picked up. We configured that tool properly. So now Spring AI is going to call your tool, your method will execute, response is going to be given back to the AI model, and then it is going to give back the response to Spring AI and then give it back here. So whatever we have drawn here end to end in one of a flow with a nice, beautiful, easy diagram, Spring team has explained also. Concept is same. Take a request, take tool information, tell it to AI. AI decides, calls you back. Spring AI should call it. AI tells you, okay, hey, call this one. Spring AI calls it, then gets the response, gives it back, and then takes it to this space. So that is tool calling feature. Nothing but you will write methods and it can be invoked. That is what it is. So let's take this and then go here. Okay. Let's take this. Let's put it here so we can have all diagrams at one place. Important thing you need to understand here, guys, is important thing here. Please note, these tools can be for retrieval purpose also, right? Let's say go to the database and only select star from, right? Retrieval. So it completely depends. Go to the database and just select star from so and so table, which it is going to just do retrieval. So you can write the tools which can retrieve read-only values, or it can update or take actions. That is where we say tools can be used for retrieval purpose also and action purpose also. Please be aware of that. Okay? And in this documentation, once this diagram is clear, they explained it all the 6 process, which is very much self-explanatory. When we want to make tool available to the model, we include this description in the chat request. Each tool description comprises of whatever information. When the model decides to call the tool, it sends a response with the tool name and input parameter, okay, whichever we have sent. The application, read this part carefully, the application is responsible for using the tool name, okay, to identify and execute the tool with provided input parameters. Means your application should do that. Since we are using Spring AI, so Spring AI is going to do it. We don't have to write much code for that. Spring AI will do that. Next, the result of the tool is processed by your application. The application send the tool callback result back to the model. The model generates the final response. I think it is very much clear here. And further, technical implementations for implementing tool, they have discussed as part of this tool calling page, where they are saying you can use the tools for retrieval purpose, for action taking purpose, and then they have given how to work with it, some simple annotations, @tool annotations, and in description you tell what it does. You can write your business logic here. Now they are explaining how it works. While making the request, how to pass the tools to the LLMs. While you are making the chat client, there you can simply say tools and provide the tools, and it is going to give you the response. Okay. Next, taking actions. Nothing but you create tools, like set an alarm for something. So action taking logic, if you write in tool, it becomes taking action tool. So tool is just a method call. Whatever logic you write in that accordingly takes a behavior. So what is a tool? A developer is writing some piece of business logic, and this tool is given to LLM. LLM decides when to run this and provides the parameters. Our application calls this, and tool enhances LLM capabilities. Tool augments LLM capabilities. That is what this is available. The concept of tools, and then this diagram we have seen, the steps we have seen, and further more details how you can use all that. So spend time in this. So I think we are done with the concept of tools also. One master session which makes us fully ready. Okay, are we clear? Guys, give a quick thumbs up. Are we clear with this? Are we clear with this? Team, are we clear with this? This is all very important information. Right now, it's available in bits and pieces on internet, and they're not very clearly available. So I felt ki chalo yaar, ek master session, definitely we should take on this. So very clean clarity, and Spring team has done very good job of documenting these things. So that was the primary source of guidance, and then exploring at other places. Okay? Tools related concept. So read the documentation. That's where I'm taking you to the source. So you rely on the documentation, understand it from there, and then knowledge clarity will be very good for you. Okay, fine. Let's continue with the next topic. What is the next topic? Third problem of Vanila LLMs. Tool capability done. RAG done. We saw it in the documentation where it belongs. Next comes memory. What is the problem of memory? Between one request and another request, LLM does not remember. LLM is like Gajni, bhul jata hai, right? I called it and I don't know. Not sure whether you guys have watched Gajni. It was, I think, 10 years ago movie. I don't know. Amir Khan ka movie Gajni, short-term memory loss case. So LLM basically forgets. Very powerful, but it doesn't have a memory. Now LLM wants to remember stuff. How in ChatGPT it works, right? Let's say, okay, my name is Tosif, and with energetic team of, let's say, our WhatsApp group, we are doing Spring AI session on 26th October 2025. If I ask any question in future, tell me this. If I ask any question in next 5 minutes, then tell me the right answer. So, fine. Ready. Ready. What topic we are discussing on 26th October 2025? Spring AI. Who are part of this connect, or who or which members are part of this connect? Energetic WhatsApp team and led by Tausif. Okay, which date is it being done? Nothing but basically memory it is keeping. Now we can to and fro talk about it because ChatGPT has added that memory related concept. In our regular Spring AI application, AI is not going to remember all this. If we ask first question, second question, it will be like, I don't know what you're saying. So we need to somehow manage this memory, and that concept is called as chat memory concept. Direct LLMs will not be able to do that. So that is chat memory concept. Nothing but we need to keep telling LLM, okay, for every request, we need to keep sharing summary of our past request to LLM. That is how chat memory is implemented. So LLM does not keep anything at your side. LLM is like, you give me something, I will respond. Now you ask LLM to start maintaining a memory for me, LLM is not going to do it because it is a universal brain which you are using and billions of people on the planet now are using LLM. It doesn't maintain any memory at their side. What LLM is saying, if you want me to remember a memory, the way you have given tools, the way you have given me RAG data, like that you provide me your previous messages also. From that, I will decide and process it. So how chat memory is implemented? LLM will not start remembering things because it doesn't want to hold. LLM is designed only once, pre-trained. GPT, pre-trained model. It is trained only once. It is not going to cache the information at its side. Point is, the wrapper layers like ChatGPT or Spring AI application, they need to write additional code where they will maintain the past messages. They will summarize those past messages and take the meaningful value. And when every API call happens to LLM, they will provide that information. Okay, that's how chat memory implementation is going to be there. So what is going to happen? You have your Spring AI application. Let's just understand the flow. You have Spring AI application and you have this LLM. Okay, you have this LLM. You have this Spring AI application. Now, point is, you do one conversation. Question 1, answer 1. Question 2, answer 2. It doesn't maintain anything between that. But in your part, in your application, you can start tracking what was question 1 and what this guy say answer 1. Then what is question 2 and what is this answer 2. You can track it in your Spring application. Okay, when the third question is going, let's say question 3, what you can do is, when the third question is going, you send a summary of all this. Either plain as it is, if you want to set, you can do that. Or you can summarize all of this together. But just imagine, you are basically sending a question 3 plus summary of question 1 plus answer 1 plus question 2 plus answer 2. In your prompt itself, this kind of data is going to go. So LLM will not start having memory. Point is, your application should combine and arrange all that data and send it to LLM. That is what these guys, ChatGPT and other guys, are doing when we are asking them question, okay, what we are doing. So now it is able to tell me okay, which date we are doing, because between them, this messaging is being communicated. Okay, what earlier conversation happened, what we are now doing. And then once LLM get all the data, it is smart enough to make a decision. Oh, this guy is asking this question. I know what is the meaning of this, and I know what is the answer for this also. So LLMs are smart in that manner, but it needs input. This is called as chat memory. Chat memory, making AI have memory. But it doesn't do it at their side. We need to do that. Please be aware of that. And this memory related part, in their Spring documentation, they have explained it here. Okay, how to work with chat memory. Okay, please note this thing. Chat memory is not chat history. That is where, while explaining, sometimes people get confused here. While explaining, I said summary of, means it's up to you. Chat history means all the questions as it is. So if you want to pass all questions as it is okay. But chat memory concept is a meaning of that, nothing but a summary of that you provide. That is what is chat memory. So it's not just a history of all your past conversation. It's like what is valuable meaning of that, because AI only needs the meaning of the main things which is discussed, and then AI can respond back. So please be aware of that. It's not just your log of communication. That's not so. In this documentation, they have explained that. Okay, it is not chat history. It is chat memory. So chat memory is nothing but a proper value out of that conversation. So that is what these guys are explaining here. You have to make a decision. Okay, hey, we want to use it for chat memory, and the information that large language model retains and uses to maintain contextual awareness throughout the conversation. Nothing but the meaningful value of the past chats. That is chat memory, and that needs to be implemented via this model. It's not for history tracking. Please be aware of that. Okay, fine. And now they provided further more explanation. Okay, they created some chat memory class in order to manage the memory and how to work with it. Everything is there. Okay, and now they have given some predefined all those objects, like you can save this memory in database, JDBC, like where the memory should be there of your past, you can save it in JDBC. You can use multiple JDBCs to save that memory. Okay, how to work with this? You can save it in Cassandra. You can save it in Neo4j chat memory repository. So where to keep this past summary of stuff? So they have mentioned it. Okay, so all this information, which classes to use. So all technical details of how to work with this is available. You can save it inside a vector store also, VectorDB. So multiple technical details of how to implement this beautiful concept. LLMs will not remember. They want to remember. So we need to start capturing that summary. Where can we keep it? We can keep it in either in memory, or we can keep it in our database. Why they have given a database approach? What if your application restarts and you lose all the memory? End customer will be like, I was speaking with it, where is my all information? So permanent storage is a good use case for this, right? So please be aware of this one also. Chat memory. In your notes, just write down chat memory. It gives memory to LLM, but LLM is like Raja. It's not going to keep memory at our side. We need to do the hard work, and that is where we call our applications as AI applications, because a lot of AI use cases we build at our side also. Okay, and then LLM works with us, and together we achieve something bigger. That's where our applications are AI applications or AI powered applications, right? Fine. Write down this thing is chat memory. We need to maintain. Okay. We already said for every request, we need to keep sharing the summary of past request. Please be aware of that. Once it is done, please give a quick thumbs up. Once it is done, please give a quick thumbs up. Then we will go to the next topic. ChatMemory. What is the approach? We need to start capturing, we need to start summarizing, and then we have to give it to them for every call. So in our application, we can have it user based, and for every your user, when you are typing your request data, we will give. When I am typing my request, so we need to do all that work. LLM is stateless. Every call is a separate call. Okay. Chalo. I know these are all very big topics, new topics, first time you are listening, but let's complete the full wide scope so that at least there is clarity. You can watch these individual pieces again, read it with documentation again, and that maybe it will take now next 2 weeks for you to properly digest this understanding. I'm not expecting one day you will become master. Maybe 2 weeks ka dedicated effort is required to watch the video, read the documentation, be comfortable with these terms, terminology. Ho jayega. I know that it will need that much of time. 2 weeks of serious work will be required. Okay. How I'm able to take this session? I have put in a lot of work behind the screen. Today is the outcome where I am able to use these terminologies very fluently because I have done it since pretty long time. Now I am discussing with you guys. So it will take a similar learning curve to become comfortable with all these terminologies, concepts, and technical working. But if you work towards it within 1-2 weeks, you will be able to talk all these things very properly during interview with your friends, and you will know what is what. Okay, fine. Chalo, let's move further. You need to understand now one more concept before we go to the next area. And we have been not discussing this topic, but the concept is context window. Okay. So whenever we provide this, like ChatMemory you are providing, okay, or RAG related things you are providing, let's say ChatMemory summary you are providing, or RAG data you are providing, right, or tool description you are providing. Basically, all this is nothing but context. Context means ki LLM should read this context so that it will make some decisions. So context is required so that LLM can work properly. Okay, so please be aware. All of this additional information which we are giving to the LLM system, we say, hey, it's context. We are giving you context. Okay, so now what is this thing? Context window. Let's be aware. Now we have again this LLM. So many diagrams today. We have this LLM. This is your Spring Boot application. Whenever our application makes an API call to LLM, we said LLM exposes APIs. So we use ChatClient internally. Some class is going to make an API call. So whenever we make an API call to LLM, it will have some reserved window or memory called as chat memory. It will have some max cap memory called as context window. Not memory, it is context window. It has a limit how much maximum it can process for that request, how much maximum it can process. It will have a limit. Okay, what does this mean? All the data which you pass it in input, you're passing data, right? This data includes all of these things, RAG related and other things. You're passing all that data, chat memory related data, RAG related, tool description, you're passing, or maybe web search karke you're passing that kind of data also. So you're passing all this data to this. Next, LLM is going to do a lot of processing, and it is also going to generate an output. It is also going to generate an output message. Now the point is, in this total number of whatever data is being processed by LLM, it is limited based upon this context window. What does this mean? While making an API call LLM, if you load thousands of documents and say, hey LLM, you don't have any past knowledge, your cutoff date is done, in my company, we have like thousands of documents. I want you to process all my documents and tell me the correct answer. Some people in the beginning days tried crazy things with LLMs. So if you load all of that data, you will automatically be crossing this context window limit, and all your previous data will be lost. So you cannot load infinite amount of data inside LLM, because it is capped for every request. It is capped by this context window limit, which says how much of input it can process, how much of output it can process. If anything is coming more than that, LLM gives up. So you need to be aware. Blindly loading huge amount of data and adding it in your context is not going to work, because a point will come, LLM will just crash. It will just drop maybe past data or stop responding as well, saying I cannot process it. So that concept we need to be aware, which is context window. And context window is having a limit max cap, and you cannot go beyond that. You have to have all your request responses messages within this much window size itself. So please be aware of that. Okay. So while sending data to LLM, ensure that you are not loading massive amount of data, since it will hit the context window size, and LLM will not be able to process. It depends on implementation. LLM might drop all your past data till that cutoff, or simply crash, simply fail the request. It depends on how those guys are implementing the LLM behavior. But please be aware. And your application might assume LLM gave me this answer, so maybe it processed everything and then gave me. In reality, LLM dropped all your 99 documents, consider only maybe the last one, and gave incorrect answer. So you don't even know that. So please be aware, there is a concept of context window. While sending to LLM, ensure that you are not loading massive amount of data, since it will hit the context window size and LLM will not be able to process. So we need to be aware. And if you go to internet, which model is having what context size, all that information you can find. But guys, write down the next concept, context window. So when we give this contextual data, there is a limit, and we can say context window considers both input plus output. LLM talks in terms of tokens, so input tokens plus output tokens. Token is about LLM internal. We have taken a 4 hours topic earlier in the past, but basically input token plus output token will be considered. So we need to be aware of this concept also. Okay, very good. Guys, write down context window, and maybe whatever one-liner you want to write about this, that is fine. And once you're done, please give a quick thumbs up. Very good to see dedication of all the people who are here and still listening. It's 3.5 hours. Sunday time, life is jingalala. But guys, 4 hours will give you different level of thinking, and it will make you better evolved. Please give a quick thumbs up if you are done till this point. Okay. There are 2 more topics left to discuss, which we will finish today only. Okay, let's go further. So we are done. We did model augmentation. So guys, let's continue, team. Let's go to the next topic. We completed this. The plain vanilla LLM was not capable to do this additional knowledge, to call or take actions, to remember things. So we say, hey, we need to do that. And in order to do that, now we understood all these 3 areas. So So we understood retrieval, we understood tools, and we understood memory also. And you can read the links. There more technical details are there of how you can implement it using Spring AI. Everything is an individual topic now to code, understand in depth. That's where now technical hands-on will be required. First, we are giving this base understanding. If you have not watched LLM internals, watch that. That will explain you about the box which we are talking, how it is taking the data, generating the data. So that was a 4-hour session, how LLM is working. Now we are doing another 4-hour session, how your application should work. And then further more topics will be there. Let's see when I come with the next topic. But yeah, you need to be practicing all these things. Fine. Now the next concept to discuss here is we created a augmented LLM. Okay, LLM with more capability. Now you need to understand there is a very weird thing, and MCP is the solution for that. So you heard about MCP already. Many people have at least heard the name MCP, Model Context Protocol. Okay, so now we are going to discuss Model Context Protocol. So please put attention why this is required, where it comes in picture. Once you get the core concept, remaining things are easy. Okay, so let's understand based upon our current situation, what have we done? So we basically just need this, a Spring AI application, which is having set of tools. Currently, we have set of tools. Fine, we have set of tools. Depending upon some requirements, we have some kind of RAG-based implementations, VectorDB or whatever. And we have some memory also. Memory, you might back it up in a VectorDB, or memory you might put wherever. This is for RAG use case, VectorDB. Okay. And basically what is happening is whenever an input request is coming inside, now when you're trying to prepare a prompt, so in that you can take the advantage of all of these things. What tools you have, what RAG related data you have, what memory you have, calling the external store and getting that data, everything is there. And then using this, we are able to call external LLM system. This much we are able to do so far. Okay, LLM system. Now, this is clear. Now just imagine we give a user query. There is an application which we are building, and the end customer says he's chatting now. Okay, let's say our project gives a chatting capability to the end customer. Now end customer is chatting and saying, create, okay, a GitHub repo for me. Let's say this is one of a requirement. Repo for me with some XYZ name. Let's say we have a feature where we can create repositories on GitHub, one of a feature. Or the user asks a question, check which flights are available and book one flight for me. Let's say if it is a flight system, this kind of thing will be happening. Or user says, order some food preference. You want something like biryani today, order biryani for me with price, let's say 150 INR, and best taste and best review, which can deliver within 20 minutes. All this is a requirement now into the system. Now, depends upon what projects you are building, but just imagine the requirements could be like this. Now, just you have to think about it from a different perspective, that you are working with LLMs. That's beautiful. And LLMs can do things. Okay, you are working with LLMs, and now LLM can do a lot of things for you. But now, in order to, let's say, book a flight, there will be some airlines system in the real world. Airline system in the real world. Okay, let's say, there is an airline system in the real world. Whatever airline you pick up. Now the user is saying, book a flight for me in this airline. Some other user is giving a query, depending upon our requirement itself, create a GitHub repository for me. Okay. Some other user is asking us, order food for me, food service. Some other guy is saying, order food from me. In the real world, some other food service like Swiggy or something is available. How do we really build this kind of a system where the user can chat and behind the screen, the work happens? In traditional sense, you take it, forget about AI applications. In traditional sense, if you want to do this, what is required? This airline system is supposed to expose some APIs. Non-AI world. This GitHub system is supposed to expose some APIs. This food service system is supposed to expose some APIs. Your backend application is now supposed to interpret which APIs I should call and who will run this logic, like, okay, price should be 150 INR, best taste, best review, and can be delivered in 20 minutes. And maybe furthermore logic, I have already bought it like in the last month. So all this logic, who is going to make that decision? Without LLM, it's not possible to make these decisions. So traditional programming cannot accomplish this. The user is now speaking like it speaks to a human being, and we are expecting a project to understand that and make it functional. Now, if you really see, this is real world other applications outside somewhere. This is our Spring application who was trying to work with LLMs. Now they are real world applications. And intelligence is required to make a decision which food service, which one we should call, which one we should not call, what GitHub required, not required. So automatically, the approach which comes here is, all these people are supposed to write tools, external people. All these people are supposed to write tools. We have also written tools. So we are expecting these external AI systems, they should write tools which will be invoked by our LLM. That's the catch here. These guys are supposed to write the tools, because traditional programming will not work here. API calls we cannot do. because dynamic decision making needs to be done. Price is 150, taste and reviews are great, can be delivered in 20 minutes. Coding cannot predict all these things. It needs artificial intelligence to really get into the detail of what the user is asking, and do we have those kind of mechanisms. So what is going to happen? All these providers are supposed to write some tools, okay, and LLM is going to decide, I want to call which tool. That is the basic concept. We have not yet launched MCP. We are understanding first need why MCP is really required in first place. But first we understood a need saying, in real world, there are many external services which do lot of functionality. Now with AI, more features and functionalities are emerging. More features, more capabilities. User can chat, and behind the screen, the output can come dynamically, right? User type send me an email, email is coming. User type send me a message, message is coming. How all this magic is happening? So, okay, in modern applications, AI capability is needed. Nothing but the brain of the system is power of LLM is needed. Okay. Now, what we are saying, we will ask all these other external systems of the world to write tools to achieve modern AI requirements. We need that external systems should write tools. Okay. And our LLM should be capable to call these tools and execute it and get response and help our end customer achieve what he or she wants. Listen this, read this part once more very carefully. Once you understood this, MCP will become really clear for you. Market में lot of discussions are there, MCP वो get it, core concept. To achieve modern AI requirements, we need to reach out to external systems, but the decision should be done by LLMs. It's not static coding the way we used to do earlier, APIs integrate and call them. No, now dynamic decision making is required, because customers will start chatting. Our applications may new features will come where with chat customers can do a lot of things. Then how they can really be connected to this world behind the screen? We developers have to build an amazing system. How it will be possible to achieve modern AI requirement? We need external systems. What is this external systems? Something like flight, something like what, this GitHub, or something like XYZ, food service, or any other payment service. PayPal is also included as part of this, guys. PayPal related service, or all these external systems. They should write tools, and our LLM should be capable to call these tools of external system, and they will execute it, and accordingly we will be able to do this. Now you need to understand, in the real world there are lot of external systems. Many external systems are there, maybe thousands, maybe lakhs, we don't know how many number of external systems. Now point is, how will one LLM be able to talk with any of these systems? There has to be standard. They can make a REST API call, but AI comes with a lot of other things. Context windows, data, memory retention. AI should be able to understand which method to call, what parameter to pass, what response is going to come back. Nothing but the traditional protocols which are available in the world, HTTP protocol, SOAP-based protocol of communication. Okay, those protocols are not designed from the perspective of AI intelligence. What is a protocol? Communication between two parties, defining guidelines for how two parties will talk to each other. SOAP, protocol. REST, yes, we say REST standards, but you can also say REST is a kind of a protocol. Nothing but guidelines of how two systems can interact with each other. Now we are in a changing dynamic world, and LLMs want to talk to these outer guys. It needs a standard. And the current standards of the world are not designed from LLM perspective and AI perspective. That is where there is a need of a communication protocol so LLM can interact with all of these systems in a standard manner. That is where comes a need of a protocol. It should not be like every guy of the real world is doing his own kind of tools. How can our LLM talk to all of these differently implemented things? No, a standard is required, a mechanism is required. So there is a need of a protocol, which is nothing but a standard way of communication, standard way by which LLM talks to external system. So guidelines, principles, something has to be there, because if every company does their own nonsense, LLM will not be able to talk. And that is where the company, once they started realizing, Anthropic, these were the guys, Anthropic company, these were the guys who were the creators of Claude. They very soon realized that yes, the systems will expand like massively, and LLMs will need to not just use their own internal tools, but reach out to the world and access the tools which is given by a lot of things. The potential exploded, and then they got into awareness a standard of communication is required, because current world technology is not capable to deal with this. They introduced MCP, Model Context Protocol. And then the world really liked it. And then a lot of people have started implementing MCP, nothing but when they are developing their systems in order to give these tools so that LLM can understand, they started implementing MCP protocol. And we never know to what extent this will come, but currently many people are using it. If in future they say no, there is a better one, because the world of AI is very dynamically changing, but now there is a huge acceptance of MCP. And even in the Spring documentation, they have provided a separate details for this MCP related topic. So Spring is providing support from MCP. Why? Because it is very common that your application will need to talk to the real world systems. How does they communicate in a standard manner? Means you don't have to keep changing. Let's say whichever LLM model you use, you should be able to talk to any other kind of tool by any other company of the world. That kind of standard needed to be created, and Anthropic team did that and offered it to the world as an open source protocol solution of how this standard communication can happen. That's where it was miracle, basically. MCP, Model Context Protocol. The naming itself says, okay, you should give context to the model, a protocol which defines this, a protocol, a set of rules, guidelines, which gives context to the model. Arey, what is context? Providing additional information to LLMs. For example, food service should expose a lot of tools. LLM will decide, yeah, this guy wants 150 INR best reviews. They should have all those tools so that LLM can call. So what are we basically doing? Providing context to LLM in a standard manner. That is MCP, Model Context Protocol. Set of rules, set of guidelines of how model will get the context from different kind of systems of the world. And that is where LLM MCP came into picture. It's been long time now, not sure how many months or maybe a year also, but yes, it is already there. Model context protocol, which says it gives a standard way for LLM to interact with tools of the rest of the world. Now that is powerful if you really think about it. Whichever company, whatever tools they have, whichever LLM they are using, connection should be there. So they caught it very quick and they quickly launched it. Even ChatGPT missed on this one, right? Even though being the market leaders, like Google missed on that one. They created attention is all you need transformer and OpenAI cast on it. So it's a idea-based world. Smart people getting smart ideas, fixing the world in a beautiful manner. That's where MCP came in picture. Okay. So guys, are we clear with the need of MCP? Can you give a quick thumbs up? People talk on internet, MCP is like a USB connector, wherever you can do whatever. But basic sense is any LLM should be able to talk with any other system of the world. That is what you understand it from this perspective itself. Any LLM can talk to anybody and make API calls, make tool calls. That's powerful if you really think. A protocol needed to be created and it happened in front of our eyes. REST may be created long time ago, SOAP created long time ago, MCP created in front of our eyes because the world is scattered. The system needs, AI needs to talk to all these things in a standard manner. So came the need of MCP and then they gave some guidelines. Now let's go one level deeper into MCP. Okay, once this basic is clear, let's go one level deeper. Good, thanks for confirmations. Now, MCP basically has given some protocol means again rules and guidelines. They gave lot of terms, 3 basic terms, guys. MCP introduced 3 basic terms as part of MCP architecture. One is MCP host, second is MCP client, and third is MCP server. ये भी ज़्यादा complex नहीं है. If you really think about it, these are also very simple things. Terminologies are different. Let me simplify things for you. Let's say this is your Spring Boot application. This is a Spring Boot application. Forget about AI and everything. This is a Spring Boot application. And currently in the real world, there are other systems which are exposing REST API. One of the way that your application can talk to this REST API is using REST client library in a synchronous style. Those who are aware of this concept, I'm just trying to give an easy reference so you can understand MCP very easily. REST client, okay, using this you can make it. Another option is web client for asynchronous communication. Now, how about you think from this perspective, you have something called as MCP client. It's nothing but for making an external call. That's it. The way we have REST client, the way we have web client, like that we have MCP client. The application which is using MCP client, we call this as the MCP host. And this application is going to further talk to now LLM systems. So it is talking to LLM systems. This is LLM. This is LLM system. So what is the terminology? You just have one object in your application called as a MCP client. The way REST client is there, web client is there, MCP client. The application, Spring AI application, we call it as MCP host. So MCP host is connecting with your LLM. It is having access to this MCP client. And here comes the magical part. This MCP client connects to these kind of external systems. For example, this food service system is available. Now, if your project needs a food service, yes, you can connect to a food service. But in order to do that, this guy has to expose some tools. MCP is a protocol. Okay, bhai, if you want to give a tool, you need to write your tools in a proper manner. What does this mean? They said, let's introduce a term for these guys called as MCP server. It's a standard mechanism. Okay, so MCP client is going to call to the MCP server. It simply gives this itself is let's not confuse the diagram. This itself is MCP server. Okay, so what is MCP server? It is going to have all the tools created which is required for LLM to make decisions. That's it. If you want to now talk to another system of the world, let's say GitHub, which is again an external system, what is required as per the protocol guidelines. Now GitHub should create another MCP server with proper guidelines. That is what protocol says. If you are creating a server, this is how your server should be created, so that any other client of the world can talk to your server. It should be that generic. So there is a guidelines for the entire world that if you want any LLM to be calling your tools, you need to make it like a MCP server. If you don't follow MCP server guidelines, other LLMs will not be able to call your tools. And if this system wants to talk to this, it will create another MCP client class object. And then using this object, it is going to talk to this MCP server. So nothing but protocol means how the two pieces should connect to each other. It is model context because these tools are going to be given as a context to the LLM model. And guys, Anthropic company has given a website directly model context protocol. And if you go to this specification and click on the architecture, you will be able to see this kind of a diagram which cleanly explains what exactly MCP is about. Look at this. There is going to be a host application, your Spring AI application. It will be having multiple MCP clients, and these MCP clients will connect to MCP servers. Okay. Now, let's go to our Spring documentation so that we can understand this same diagram from the perspective of what Spring team has done. What is Spring team saying? Your Java GenAI application, nothing but again AI application, which is MCP host. This guy is talking to multiple AI models. Plus, this guy wants to talk to systems. Let's say these two are external systems. This is a food system. This is a GitHub system, external systems. How do they work with it? They will be having MCP clients. You will use, because you are working with Java, so you will use Java MCP clients. And then for making external call, there is a guidelines of how your MCP clients can connect to MCP server. There are guidelines. It is created in that manner. Now, there is a different concept. We can run the MCP server in local machine also. Why it is required, we will discuss that later. But for now, just understand this. Your application is MCP host. It will need MCP clients to talk to MCP servers. MCP servers can run outside. MCP server can also run in your local machine also. So when you relate these many diagrams together, basic understanding happens. Even if you see this, there are multiple clients. There are some which is running in your local machine, some which is on internet, and MCP provides a mechanism how you can work with this. For example, let's say developers of these guys. Let's take a simple example. The people who are developing food service, they want to do the testing. So they need to run their MCP server in local machine and access like that itself, right? For us, it is remote, but the developers who are developing it, they need to have local connectivity also. That is what this is. So you can run MCP. So what is the topic here? Okay, MCP host, the application. Okay, the application which connects to LLM and uses client to do the work. Client is nothing but connects with server, and server is nothing but exposes the context needed for LLM. Currently, we said tools they are exposing. There are a few more concepts. Let's not get into the details. Resources and prompts also they can expose. So this all is part of the context which will be exposed by this. Clients are going to call it. That is what we are discussing. Next concept is MCP servers can run in local machine also as well as remote also. Okay, MCP protocol is giving guidelines how to connect with local MCP server versus remote MCP server. They have given guidelines. Okay, you can find more about this architecture here. You can read more about this in Spring related diagrams also. It's all clearly explained how this communication is going to be. And okay, MCP says how you can do it locally running versus remotely running. They have specified something called as transport here, where they are saying if you want to run it in your local machine, this communication style is there, stdio, standard input output. Local, if MCP client and MCP server, a protocol, right? The protocol means terms will come, network calls will come, guidelines is there. How to make a network call? Protocol is defining guidelines. Local, if you want to do local communication, stdio, standard input output. Remote call to MCP server, if you want to do. Then they have introduced something called as Streamable HTTP. Everything, it's a protocol, guys. The way HTTP REST API is a guideline protocol. SOAP is a protocol. How to really make a call, right? Even these are protocols. So they went to that level, okay, defining how the session is going to be. If you read this further Java related, they will tell you it is a layered kind of protocol where MCP client will work with MCP session, which will use MCP transport and then use the communication protocol like stdio or SSE. What is SSE? Again, in Streamable HTTP, they have provided some way of doing it via SSE, server side events. Again, internal concepts. But basically, MCP is a big guidelines of how these two systems should talk. Now, there is a lot of internal depth to it. If you really want to understand to the level of how MCP architecture is internally operating, yes, that option is available. You can go to their diagrams and you can spend time there. But as a regular developer, you just need to understand this high level stuff that in the world, LLM wants to talk to any other external system. There are guidelines for that. If you are interested in going under the hood, yes, options are there, but you will not need it on a day-to-day basis because simply Java objects, you create MCP client, call a method, and you will be able to reach out to them. So, but if you want the internals, yes, that option is there for you to understand from multiple perspectives. So they have given this kind of a diagram in the architecture. Host, multiple clients, your MCP servers can run in local, and then they will be having whatever logic, or MCPs can be external, and then they will have whatever logic. Okay, fine. And then they described about host, client, server. Already this URL is added in our session notes also. There is one more very interesting thing about MCP. Protocol ka khel hai, guys. A project where LLM AI application is developed in Python. MCP server can be developed in Java. If MCP server is developed in Java, invoker code MCP client can be still Python. Cross it can be there. Okay, MCP server could be Python or Java or any other programming language, Go or Node.js, whatever. From Java application, we can still talk to any other. Why that is happening? Protocol is the mode of communication. Same thing happens with REST also, right? REST API, we write it in Java, but Python can also call your REST API. So MCP also gives that language compatibility. Server can be anything, client can be anything. They can still interact with each other. That is another point you need to understand. Okay, so language compatibility is there. Server can be anything, client can be anything, any programming language, and it still works because they took care of that while designing the MCP architecture. Okay, fine. And in the Spring related documentation, they have given one example of this scenario also. Just observe. They gave things. This is standard input output, nothing but in the local machine. This is streamable HTTP. Earlier they launched SSE, and after that they have upgraded the model to support this second architecture, guys. Earlier, just see, in this transport mechanism, earlier they created stdio and SSE. Let's see, just observe here. Streamable HTTP replaces the HTTP plus SSE transport. So when they earlier launched the model, in order to make call to external MCPs, they introduced the concept of HTTP plus SSE. And looks like the Spring related team developed all these document and integration when the initial clarity came. After that, these model guys have made modification saying streamable HTTP. So that is the reason you will not see the streamable HTTP still documented by our Spring AI team. But I think in future releases, they will fix all this and then they will adapt. That is what AI world is dynamically changing. So when they developed it, it was all based upon this SSE mode of transport. But please be aware, stay up to date. Yeah, so now there is streamable HTTP, just a mode of transport. So what are we discussing? Look at this diagram and you can understand. stdio is for local and streamable HTTP is for this one. Spring is saying SSE because it's the earlier way. Even if you want right now to use SSE, that is possible, but just be aware of these things. Second thing to learn from here is observe. Python MCP client can talk to a Java MCP server. The protocol takes care of that compatibility. Java client can talk to a Java server. JavaScript client can talk to a Java server. Cross thing is available. And when you are trying to make external call from your laptop, you're running all these things. Okay, it will go via one proxy if you're trying to talk. Nothing but it's all possible. Compatibility is there. That is the point to be understood. So what we will do is we will take a image of this one. So you need to just get this clarity in order to technically implement MCP. If you have tools to be exposed, which will be called by LLMs, not just of your project, but from other companies also, then you have to go ahead with MCPs and develop MCP servers. And if you want to call these kind of clients, even from other company, then you have to create MCP clients. So it depends upon your situation. But yes, this is the architecture or protocol style of using MCP. I think we have the base clarity of why MCP came in picture and what is the purpose of this one. So this is MCP. This is the first diagram. This is the first diagram. Next diagram, we can find some nice useful things from our Spring related guys also, which explains converting it into a Java based style. So this is also helpful. Let me consolidate this also for us. And they have given this nice one more diagram. So we can take some learning from this one as well. That much we need to be aware of how MCP and be ready even if this changes in future or some more guys come up with a different protocol. So it can change as well. So we need to be checking how the world is shaping up with all this. Okay, that is the concept of MCP. Technical implementation, you can read from these other documents. The features, MCP server capability, MCP client capability, okay? And it is saying like tool discovery. Means whatever tools are available in MCP server, MCP client can find all those tools and make it available to your Spring AI system so that it can give it to LLM. Next, whenever LLM says, hey, call that external MCP server, so our MCP client will call that external server. Then external server will run it, get the response. This response, we will again give it back to our LLM. So the way local tools we discussed earlier, like that now we are discussing remote tool mechanism by using MCP server. The way locally we were operating, now we are operating with a remote, and the world is very scattered. So a protocol was required, and that is where it came with MCP, Model Context Protocol. Okay. Further, how to develop client, how to develop server, everything is available here. MCP client, if you want to create, what are the guidelines? How is the code piece? What are the configurations? Server you want to make, what about that? Everything available here. And so this is a good section for you to deep dive into MCP capability. But this much of knowledge everybody should understand who are in the world of AI right now. Are we clear with it, guys? Please give a quick thumbs up. Are we clear with it? It's already 2 hours. It's a very long session. Are we clear with this, guys? Give a quick thumbs up. Okay. Some of the guys are doing it. Okay, एक ये भी लगता है like okay, public are just live 39 members there, but they left their laptop and doing something else. I'm talking to myself only. No, but good to see your responses that okay, you are there. Okay, you are there, you are listening, you are grabbing, you are understanding. It's required. Okay, it's required. There were a lot of people from previous time. They say, sir, your sessions are like 3 hours. Our mobile data gets completely empty. But yeah, kya kare? The topics are that important. It cannot be rushed. It needs to be understood quickly. It's not a world of shortcut. 15 minutes may teach me MCP. No, the behind the screen, you are going to use MCP for the next coming years if MCP really stabilizes. So 15 minutes mein kahan jana hai? Where do you want to go in 15 minutes, right? So you have to spend the time required to understand the right things, no matter how much. If it is needing 1 day to just understand MCP, full 1 day, 24 hours, then also that is less, because there is so much to dig in. RAG you want to understand, 1 week you spend only on RAG, you will find so many things. So don't rush in learning. Okay, 30 minutes I want to learn everything. No, you will not get the right knowledge. The world is far too advanced. It cannot be captured essence in 30 minutes talk, no matter how much you look for it. You need to deep dive, and once you know it, there is further more to know and further more to know. So patience and digging is required, and you are building a career for the next 20 years. Can't you spend few months in strong preparation? So that is what is required. Okay, fine. Now guys, the last topic we will discuss of all of this today's discussion, the final topic, and then we will complete the session. Okay, but now can we take another poll before we move forward? I think you are already in a shape. In the beginning we asked a question. GenAI LLM vector RAG, and now we have completed tool memory context MCP, all the remaining sections also. Let's do a final poll and let's see now what is the confidence level. Okay, so guys, I'm putting another poll here, and uske baad there is one last topic we need to discuss about agents, right? We need to get some clarity about agents and agentic systems. So that is where the world is now moving into. It is further advanced on top of what we have discussed so far. Okay. So we will just launch it to get some clarity, and then we will go further. Then later we can have maybe some other session to deep dive into those things. Chalo guys, what are the topics? Gen AI, LLM VectorDB, LLM VectorDB, RAG, tool, memory, context, MCP. Are you confident in this one? Yes, I am confident. Means you can discuss this with somebody. Again, let's say 50-50. Because not knowing is not an option. If you're listening, you should understand. So third option does not exist. If you're listening, you should understand. Chalo guys, please mark this poll. Let's see from 40 members, how many are active? 7 members are active and they are very confident. Kya baat hai? Let's see how our poll comes in 4 hours. Okay, 10 members voted. Percentage wise, we need to see. 75% is having confidence. 79. Anybody else? 80% having confidence. Basic cheez aa jayega. That's what I'm saying. Get the initial clarity. I'm not saying you became a perfect master in this. Now you have to read this, watch this again, explore something. Then perfection will come. But at least initially, now you're not blank. What is being discussed when people talk about all these terms? Now you can analyze and dig further. But guys, let's look here. Within 4 hours, 17 members have right now voted, and we have reached to a state where 80%, 82 to be more precise, is now saying, okay, it's in the bag. AI terminology is it's in the bag. There is next level. What itna to? Now you're not blank, right? One Sunday is enough for getting started. So let's put this as well. And what do we see? The transition of the full topic. This is how the flow is. Yeah, the polls and all depending upon the people. Okay, but point is, if all the members who met here till the 7 and saying I am confident, okay, that means from 80 people who were there in the beginning, right now you are the maybe top 15, top 13. Now you can imagine when the interview happens, you have a better chance than rest of the people. Maybe they will watch the video again and then prepare, and then they are also in the race. But please be aware, competition is not there in the market, because the people who are willing to put efforts and gain the right knowledge and showcase it during interview, those counts are very different. This is what I'm trying to say. So be in the race, be there. You will get it. You will be confident. You will get jobs. Companies will need good people, and others might not make it till the end. So you have a very good chance if you are dedicated and working towards your dreams. This is what I just wanted to say. So this is a good thing that you made it till the end and others were not able to do because of whatever reasons. You have a chance to upgrade further and get better results always. So competition is not there. 80% will not even reach the destination. All the guys who are there in the call right now, you belong into the top 20. And later, those people who will watch the recording, I'm talking you also, you are also in the top 20, because 80% will not even reach to 4 hours of this discussion, no matter how important it is. And that is a weakness of human being. You know what is needed to be done, but majority of human beings will not be able to do that. So if you are doing it, you have chance of success. That's how success and failure is created on this planet. Fine. Let's discuss the final topic and then close the today's session. Areva, 25 people voted. Very good. I think we should take a screenshot again. So we have now consistent. Earlier also your 25 were there. Now also 25 are there. So now we have a equal poll. So we can see now more people are saying we are full confident. Earlier 96 were saying basic hai, but now I am good with these. वो category में majority will belong. That was is this poll about. Yes, I am confident means I am good with these. We change the equation in 4 hours itself. Let's discuss the final topic and close the day. Maybe 10 minutes discussion and we will complete it. As the field of AI is advancing, okay, as AI is growing more, people started using this LLMs, started building all of these kind of systems, application talking with LLMs, vanilla flavors. And after that, they started upgrading, working with multiple these things. And then Spring created all this, it's fine. And then they started upgrading the capability of LLM and making it augmented LLMs. It started doing that. Then the applications of the world started connecting with one another. So that is where MCPs came in picture, RAG capability, tool capability. We discuss all this. But major thing is MCPs of the world came in picture. So one application can now talk to another application. This is where the world has reached so far. But now let me tell you a complicated scenario here. In front of our eyes, there is a problem. And that is where the further work of AI has already happened. We need to understand. Okay, what is the problem here? Let's try to understand. One use case we will understand. It will make it very clear for you. Now let's imagine. We are saying whenever any tools are created, listen this part carefully. Past knowledge is required, which we discussed 1 hour ago. When we create tools, we provide descriptions. Descriptions of the methods, what parameters, we create descriptions. Similarly, when all these MCP servers of the world have created tools, they will also have descriptions, huge descriptions, because descriptions help LLM to make a decision when to call certain tools. So everybody will write huge. Now, let me give you a problem statement. You are building a Spring AI application, and we know how the tool nature works. We know how the tool nature works. Let's go to this tool calling diagram. How the tool nature works. While passing the request to the AI model, we need to give AI all the list of tools with the details. Then AI decides, okay, which tool needs to be called. Now understand the problem here. If you integrated with 100 other MCP servers, these 100 servers, every server might have, let's say, 50 tools. You have tools, these guys have tools. 5,000 plus tools there. 100 servers having 50 tools each. 5,000 tools. You can imagine. 5,000 tools total. And what is the basic mechanism of talking to LLM? When you make a prompt, you need to give the details of these tools so that LLM can make a decision which tool to use. And this is a blunder situation. This concept or this terminology is called as tool explosion. Tool explosion. Huge number of tools fed into LLM, and now LLM is going to, like when a user query is coming, LLM wants to make a decision which tool to call. Some confusion might come to LLM. Its decision making might vary because some tools might be relevant, some might be irrelevant. Question comes, for every query, should we get all the tools and give it? If you're talking about a food service, get only food service related, right? Why do you need other? If you're talking about airline, get only airline related. That means your application should decide for which query, which tools I should pick and tell to the LLM. This is how complications have started happening in the world. Okay. So first, let's understand the scenario. We have 5K tools. And while sending request to LLM, we need to send possible tools which LLM can call. So the question, we have 5K. So for every request, do we send 5K tools? Answer is no. Then comes the second question. How do you decide which tools to send for that request? This is the question which is there in the mind of people. And a lot of guys, smart architects working on these big organizations, came up with some elegant solution for these kind of situations. Let me tell you the solution here, and you will find, okay, wow, this is beautiful. Okay, the solution here is something like this. Listen to this part very carefully. Now, it's an architectural solution. 10 people will solve this problem in 10 different ways. I am recommending you one of the solution which I found, okay, wow, this is really a good one. Okay, so what is that solution? You have your Spring AI application, guys. Listen to this part very carefully. It is very important to understand the need of agents and agentic systems. So this clarity will come if you understand this solution. So there is a need. Okay, fine, there is a need. What is the need? Spring AI application is there, and in the world there are n number of tools available, 5,000 tools available. You are connected to those 5,000. You have MCP clients which can connect to all those 5,000s, 5K tools. But when you're talking to your LLM, you need to provide only the relevant tools. Otherwise, LLM will make wrong decisions, call something else weird, things will start happening by your application. So step number 1 is something like this. You will take all of these tools, descriptions and everything, and load it into a vector database first of all. We will do RAG-based handling here also. Observe. All the descriptions of the tools, that is where people say it is tool RAG. There is a terminology which you might find somewhere, tool RAG. Why is it required? To solve this problem. When there are tool explosions, many tools available, LLM, we have to feed the relevant ones. So how we are going to do that? Okay, we will take all these tool descriptions and put it here into a vector database, VectorDB. We will put it into VectorDB. All the tool descriptions. Next, what is going to happen? Whenever, listen this part very carefully, it is very interesting, guys. I liked it when I saw this approach. When the input query comes, we know vector database is for similarity search. What we will do is, we will take this query and query it for similarity search in VectorDB and get only relevant tools. Get only relevant tools. Maybe out of 50,000, it might give us maybe 50 tools or 20 tools. We can ask to what extent we want it. The best possible tools which is required for this user query. So this is step number 1. This is step number 1. Once you get these 20 tools, okay, you need to give to LLM. Should you give all the 20 tools? Because RAG is saying, dekho, vector database, it has some intelligence, but it is not artificial brain. LLM is an artificial brain. It can make decisions. Vector database will do pattern matching and try to find the relevancy score and give it. It's not that intelligent. It does similarity search. So 20 it gave, but not all of them might be perfect match for this one. This is what is the next concept, and it is beautiful. What people did, they introduced another concept in the world called as mini LLM, or even some people say small LLMs, large language model, small language model, SLM or mini LLM, which is generally trained on less number of parameters. Lightweight, not the actual one, it is lightweight one. That is the second step. You take all these tools and the user query and you give it to this mini LLM or a small language model and ask, give me the top 5 and arrange it in the priority also. So step number 1 is working with this, pulling the relevant tools, but it might still be generic because your intelligent braining is not happening. Then you do step number 2, which is nothing but speak with LLM systems, small language models, which is again a language model itself, but trained on less number of parameters. It will try to do its best. Lightweight, less charge it will come for using it. And it is going to tell you, okay, let's say the top 5, and you will ask it, okay, reorder it properly. That is step number 2. And guys, step number 3 is what we have already seen. When you are passing this user thing, prompt to LLM, pass those 5 ones. So it is a 3-step solution. Then step number 4 comes, LLM is going to pick the right tool. LLM, pick right tool. LLM, pick the right tool. And then it is going to inform back to our Spring application, which is a AI application. Okay, use this tool T25. I'm just giving a number. Then your Spring application is going to use the MCP client, which talks to the MCP server where this tool 25 is residing. So it talks to like this MCP client, and the tool 25 is residing here inside its MCP server. And then your host will reach out to this client and call that, and then response is going to come back here. And then you will give it back to this LLM, and then that portion remains the same, but it is external and standardized communication because of MCP. But now, guys, the problem which we had was how to give only relevant tool, and how have we solved it? 3 steps. First, find the relevant one from the VectorDB. Second, call a small language model to get the relevant ones. Third, call the large language model. And if your prompt says, after this first call, you have to do another MCP call, you're realizing the requirements are exploding. Requirements are growing. Step number 1, maybe need of small language models. Step number 2, call the LLM with right tools. Step number 3, once step 1 is completed, maybe you want to send email. Step number 4, for sending email, you need to connect with another MCP server. Let's say Google gives a MCP server. You need to connect to that Google related MCP server to send the message. Nothing but observe, one requirement is needing lot of communication. And that is where, when you code the system in this manner, we say AI agent. We are building an AI agent which can understand a requirement and then can call tools, internal, external, and step by step progress to complete a given task. That is where AI agents come into picture. Okay. However, Anthropic team has defined the world of agents in 2 basic forms. So the applications which are using LLMs, those AI applications, they said generally 2 kind of integration is there. One is workflow based applications. Second one is agent-based applications. And when they are saying agents, they are basically saying it is autonomous agents. Nothing but there is a task in hand. In order to do that, a lot of sub-steps are required. Complication is there. You need to do this, then check the result, then do that, then check the result. So these kind of applications where heavy utilizations of LLMs are happening, as per Claude Anthropic, they are called as agentic systems. Heavy utilization of LLMs is happening for many use cases. They call it as agentic systems. And then they categorized as workflow and agent base. Workflow means there is a standard defined path, the way we created. This is a workflow. Okay, first you talk to a small LLM, give only relevant information, get the response. After that, you talk to LLM. Nothing but standard pattern is there. Standard path to execute, that is workflow based. Autonomous agent, this is nothing but your agent itself makes all the decisions. You just give the required information. Agents is going to decide when I should call small LLM, when I should call the RAG system, when I should call other external tools. Everything is done by agent itself, and it does it autonomously, means without much user inputs also. Okay, and in this blog, which is given by this Anthropic, that is what they have explained. I would suggest you to read through this one. What they are saying, over a past year, we worked with dozens of teams building large language model agents across the industry. Means lot of logics around LLMs, where there is a task, you break it down, you execute it. They studied all that, and they have some observation that is fine. What are agents? Agent can be defined in several ways. Some customers defined an agent as fully autonomous system that can operate independently over extended period, while using various tools to accomplish a complex task. Others term to describe more prescriptive, nothing but you guide LLM properly. At Anthropic, we categorized all these variations, means multiple ways to use agents. They categorized it as agentic system, but basically they grouped them as workflow and agent. And then how workflow based, so they have started to explain all those things. So stage number one, the building block is LLM should have this capability. Then they started going workflow, means how one LLM call, then doing something else, other LLM call, means a sequence of work will be there. And they understood all those patterns. When, what will be required. Router LLM call can be there to, means one task, many things to happen. Many LLM calls, many decision making, many tools. All of that they have described here. Okay. And then they go into the final section where they speak about agents related. Why do we need autonomous agents? So that they take care of it and how it is going to be. Okay. And Spring team has provided a last blog here where they are saying, let's say in the guide section, building effective agents. In that they are referring to this blog which is given by Anthropic, and they are saying, okay, yes, stage number one, we will do this. And for all the patterns, workflow and agent, how to implement these patterns using Spring AI, they have given code examples. You want to implement workflow pattern, call multiple things, how to do that, code examples they are giving for parallelized workflow and other things also. So this agentic world means extensively using AI. Multiple calls will happen to accomplish something really big. Multiple tools will be called, databases will be called to achieve something really big. Either you can create it as a pattern, which is workflow, or you let major LLM make the decisions for you, and that is more in a autonomous manner. But it will take a task, break it down into 10 steps, execute the 10 steps, do whatever is needed for the 10 steps. That's what is the next world of agentic systems, where heavy interactions to and fro is happening. with these kind of things. So I think on that note, we would like to complete our today's session. Know that future will have more and more agents, more and more agentic systems, more autonomous features will be there, more automation will be there. But reaching to that means you need to understand everything what we discussed today. And if you really go through this, I think we have covered almost majority of it. Next, basic features are there: observability, testability, but those are simple features, not required to discuss. But otherwise, we are completed with this. You go to the reference, you can chat client, prompt, structured output, multimodality, working with multiple models, chat related models, MCP. Next, once these models are done, chat memory, tools calling, MCP, RAG, ETL, model evaluation we have not seen. Means when the model is responding, how to check whether it is proper. We have not seen that. But vector databases, observability, we have not seen. Monitoring, how it is performing, we have not done that. But almost we are done with across the features of Spring AI. Okay? So thank you everybody for joining this Sunday. I would request you कि एक एक टॉपिक को you catch it, read the documentation, explore on internet, explore on maybe other YouTube or courses or whatever platforms, work with ChatGPT itself to get more knowledge, but get each of the concept. I did not get into much details about the agentic systems and all that, but at least I took time to launch it today so that you can just understand one use case we took, how we need to talk to multiple systems, and LLM will be doing that. So we launched AI agents and agentic system. In future, we can have another discussion to get deep dive into this. Lot of thing needs to be done. Okay? Thank you everybody for your time. Long session, almost 5 hours we are going to hit here, right? 4 hours 50 minutes. भाई साहब आज तो 5 घंटे का सेशन हो गया, but it was required to finish in one go. ठीक है? Thank you for your time. All the best. We will keep updating things. If you are not in our WhatsApp group, please join our WhatsApp group. We will share all the recordings, updates, not this one. Where is our WhatsApp group? This one. If you are not part of the WhatsApp group, please join this group. There we will share recordings, notes, and all the other information. Okay? Chalo guys, thank you everybody for your time. Have a great day and have a great Sunday. Bye-bye team. Take care of yourself. Bye-bye. All the best. Take care of yourself guys. Stopping the stream. Oh, 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 oh.